Hi guys, it's Red. Today we are going to install Python and VS Code. Let's get started. First of all, open your browser and search for Python. Click on the first link, Welcome to Python. Downloads and click on Python 3.12.0. Once the download is complete, click on it. Now follow my steps. Make sure to add Python to path and click on Customize installation. Click Next to proceed. Click on Install and simply wait for the process to complete. Click on Close. And now reopen your web browser and search for VS Code. Click on Visual Studio Code. And click on Download for Windows. Again, wait for the download to complete. And once it's done, click on the downloaded file. Accept the agreement and click on Next. 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 Next again. And finally, install. Select Launch Visual Studio Code and click on Finish. On the left side, click on the Extensions button. In the Popular section, click on Install Python. If you don't see it, search for Python in the navigation bar. Now you're ready to start this beginning tutorial. Thanks for watching and see you in the next lesson. In this lesson we are going to create our first Python program. Let's get started. First, create a folder for the entire course and name it Python Tutorial. Open VS Code. Open the nearly created folder. Yes, I trust. Close the welcome page. And now let's create the working file. Lesson 01 hyphen string .py. Don't forget .py, because the .py extension is signaling to the interpreter that we are going to program in the Python language. Now let's create our first program. Print parentheses quotation mark hello world. Click on the triangle in the upper right corner to run the program. And the phrase hello world will appear in the terminal. Now let's analyze it. We use the print function capable of displaying everything inside the parentheses. in this case a string. You can recognize a string because it's delimited by quotation marks. You can use the print function in many ways. Let's try another use of the print function. Print, parenthesis, quotation mark, hello, quotation mark, comma, quotation mark, world, and run it. The compiler has processed our program line by line. In the first line, it identified an instruction to print the string hello world. In the second line, it identified an instruction to print two strings separated by a space, which is why we obtain again hello world. This illustrates that in programming languages you can achieve the same result in different ways. The rule is to choose the best way, and if there isn't one, stick with the most comfortable approach for you. Now let's discover another way to print hello world. So print, parenthesis, quotation mark, hello, quotation mark, plus, quotation mark, space, quotation mark, plus, quotation mark, world, and run it. Another hello world, but this time we concatenated three strings using the plus sign. As you might have noticed, an issue arises when try to insert a quotation mark inside the string. So let's try it. Print, parenthesis, quotation mark, I'm a string. Quotation mark. As you can see, the apostrophe terminates the first string, and the third quotation mark at the end opens another string, and the characters in the middle are not recognized. One way to solve this issue is to use the backslash. Let's see how. Backslash and run it. And as you can see, we obtain I'm a string. Another way to solve the issue would have been using double quotation marks to identify a string. Let's try. Print, parenthesis, double quotation mark, I'm a string. And run it. Now let's try to use backslash to create a new line. Print, parenthesis, quotation mark, line 1, backslash n, line 2, and run it. Line 1 in the first line, line 2 in the second line. We can even use the backslash to tab a line. Let's try it. Backslash t and run it. And as you can see, the first line has a tab. Talking about special character, the hash it's used to create comments, providing useful information for the programmers to understand the code quickly. Everything after the hash will not be considered or printed. Let's create our first comment. Hash, I'm a comment. As you can see, it's not been printed. To recap, let's create another comment using the triple single quotes. Lesson 01, hyphen string. So we learn about string, we learn about the print function, and we learn how to concatenate and to use the backslash to create an apostrophe, a new line, and a tab. And lastly, we learn 2 ways to comment on our program. For this lesson is enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about variables. Let's create the file. Lesson 02 hyphen variable .py. And let's create our first variable. My underscore name equals quotation marks red, and print it. Print parenthesis my underscore name and run it. So a variable is an identifier, in this case my underscore name, which is associated with a value, in this case a string red, that we can reuse as many times as we want. A variable inherits all the properties of its type. In this case, it's a string, so we can concatenate it with a string. Let's do it. Print, parenthesis, quotation mark, my name is, space, quotation mark, plus, my underscore name, and run it. Now I'll introduce you to the input function, enabling interactive interaction with the program during runtime. Name equals input, parenthesis, quotation mark, enter your name, colon, space, and print the name variable. Print parenthesis name. Run it. Running this code prints what's inside the parentheses of the input function, and the program waits until the enter key is pressed. Then assign everything we write to the name variable and proceed to the next line where the name variable is printed. So let's type our name, red, and push enter. And then the name has been printed. Now let's create a new variable, greet equals quotation mark hello, quotation mark, next line, print parenthesis greet, comma, name, and run it. Red, enter, red, and hello red. Let's recap. Triple quotation mark. Lesson 02 hyphen variable. We learn what is a variable and how to use the input function. For this lesson is enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about a new type, the integer type. But first, let's create the file. Lesson 03 hyphen integer.py. Let's create a variable n1 equals 5 and print it. Print parenthesis n1 and run. Running the code gives us 5. Now let's create a string s1 equals quotation mark 5 and print it. Print parenthesis s1. Run it. We obtain again a 5. But how can we determine the type of a variable? To ensure n1 is an integer and s1 is a string, let's use the type function. Print parenthesis type parenthesis n1. Again in the next line, print parenthesis type parenthesis s1 and run it. And as you can see, the class int stands for integer and the class str stands for string. Now let's try to concatenate two integers. n2 equal 3, print parenthesis n1 plus n2 and run. As you can see in this scenario, the plus acts as an arithmetic operator. If we want to concatenate, we need two strings. So let's transform one of our integers into a string using the function string. Print parenthesis str parenthesis n1 plus s1 and run. So in this case we obtain 55. Now let's discover all the arithmetic operators available in Python. Print parenthesis n1 minus n2 and print parenthesis n1 asterisk n2. Print parenthesis n1 slash n2. Print parenthesis n1 double slash n2. Print parenthesis n1 percent symbol n2. Print parenthesis n1 double asterisk n2 and run it. n1 minus n2 equals 2, n1 by n2 equals 15, n1 divided by n2 equals 1.66. The integer part of n1 divided by n2 equals 1. The remainder of the division between n1 and n2 is equal to 2. n1 to the power of n2 is equal to 125. Now let's recap. Lesson 03 hyphen integer. We learn about integer. We learn the type function. We learn the str function. And we learn the arithmetic operators. Plus, minus, asterisk, slash, double slash, module, and double asterisk. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about a type closely related to integers, the float type. Let's begin by creating a new file, lesson 04 hyphen float.py. Let's create a float variable f1 equals 3.6 and print the type and the variable. Print parenthesis type parenthesis f1 close the parentheses, comma, F1, and run. As you can see, the type is float. Floats are numbers with a decimal part, but it's not necessary for that part to be present. For example, F2 equals 3 dot, and print again the type and the variable. Print parentheses, type parentheses, F2, close the parentheses, comma, F2, and run. Here we obtain a float even without specifying the decimal part. Now let's create an integer, and 1 equals 10. And now F3 equals n1 slash n1, and print the type and the variable. Print parentheses, type parentheses, F3, close the parentheses, comma, F3, and run. Again we get a float. That's because any division returns a float, except when using double slash for integer division. Let's try it. n2 equals n1 double slash n1. Print parentheses, type parentheses, n2, close the parentheses, comma, n2, and run. As you can see, the double slash returns an integer. That's because there are no float in the division. Now let's try with the multiplication. Print parentheses, type parentheses, n1 by f3, close the parentheses, comma, n1 asterisk f3, close the parentheses. Run. In this case we obtained a float. That's because all the arithmetic operation with a float results in a float. Now let's transform an integer into a float using the float function. n1 equals float parentheses n1, close the parentheses, print parentheses, type parentheses n1, close the parentheses, comma, n1, and run. Now let's try to transform it back into an integer using the integer function. n1 equals int parentheses n1, and print it again. Print parentheses, type parentheses n1, close the parentheses, comma, n1, and run. And we obtained an integer. Now let's recap. Lesson 04 hyphen float. We learned about floats that are very similar to integers. We learned about the integer function and the float function. For this lesson is enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about a new type, the Boolean type. First, let's create the file lesson 05 hyphen boolean.py. Let's create our first boolean, t equals true, f equals false. Print parentheses t comma f and run it. And we get true and false. True and false are the two values that a Boolean can assume. Now let's discover how, starting from these two values, we can create more complex logic using logical operators. The first is the AND operator. Print, parenthesis, T, AND, F, and run. As you can see, we get false. That's because the AND operator takes two operands and returns true if they are both true. In this case, F is not true, which is why we get false from this operation. Let's try to get true. Comma, TNT. Run. And true it is. Now, let's discover another logical operator. Print, parenthesis, T, or F, and run. In this case, we obtain true, because the OR operator returns true if at least one of the operand is true. Let's add another operand, or F, and run. As you can see, it's still true. One true is enough to return true using just the OR operator. Let's try to get false, comma, F or F, and run. Now let's discover the last logical operator, the NOT operator. Print, parenthesis, not T, comma, not F, and run. The NOT operator returns true if the operand is false and false if the operand is true. Now let's talk about the comparison operator. Let's create a variable b equals 3 double equals 3 and print it. Print, parenthesis, type, parenthesis, b, comma, b, and run. b is a Boolean type with a true value, because the comparison operator double equals returns true if the two compared elements are the same. In this case, they're both 3. Now let's explore the other 5 comparison operator. Print, parenthesis, 3, exclamation mark, equals 3. New line, print, parenthesis, 3, greater than 3. New line, print, parenthesis, 3, less than 3. Print, parenthesis, 3, greater than or equals to 3. New line, print, parenthesis, 3, less than or equals to 3. And run. As you can see, we get false because 3 is not different than 3, it's not bigger than 3, and it's not less than 3. But we obtain true because 3 is greater or equals to 3, and 3 is less than or equals to 3. Now let's recap. Lesson 05 hyphen Boolean. We learned about Boolean, we learned about logical operators, and or not, and we learned about comparison operators. Double equals, not equals, greater than, less than, greater than or equals, less than or equals. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about the if statement, a fundamental control structure that allows you to conditionally execute a block of code based on a specified condition. Let's get started. First of all, create a file, lesson 06-if.py. T equals true if t colon new line print parenthesis quotation mark t is true. Don't remove the indentation and run it. So if the condition, in this case t, is true, everything indented after this line will be executed. What if the condition was false? Let's try. F equal false if f colon new line print parenthesis quotation mark f is false, and run it. As you can see, just t is true has been printed. In order to execute something when the condition is false, we need another statement, the else statement. Let's create it. Here we change f is true, else column print parenthesis quotation mark f is false, and run it. And this time we also get f is false. Now let's try something more advanced. X equals 1 and print x, and if x double equals 1 colon print parenthesis quotation mark x is equal to 1, and run it. X is equal to 1. But what if we want to have more conditions? For example, if we want to know if x is less than 1. In that case, we can use the elif statement, specifying a new condition. We can use as many elif as we want. X equals 0 and elif x less than 1 colon new line print parenthesis quotation mark x is less than 1, and run it. As you can see, we got x is less than 1. Now let's make x bigger, x equals 2, and let's add an else statement. Else column new line print parenthesis quotation marks x is greater than 1, x less than 1 colon new line, and run. Now what if we want to know whether x is equal to 0 or negative? We can use a nested if. Let's try. Let's comment this line. If x double equals 0 colon print parenthesis quotation mark x is equal to 0. Else colon new line, print, parenthesis, quotation mark, x is negative. Let's set x to 0 and run. And as you can see, x is equal to 0. Let's set x to -1 and run. X is negative. That's perfect. In this way, we have covered any possible value of x in the vicinity of 0. Now, let's talk about the ternary operator. It's a way to use the if statement a little differently from what you've seen until now. Let's try it. Result equals quotation mark, x is even, quotation mark, if x modulo 2 double equals 0, else quotation mark, x is odd, quotation mark, and print the result. Print parenthesis result and run it. X is odd because is equal to -1. So if the condition is true, we obtain what's before the if. If the condition is false, as in this case, we obtain what's after the else. Let's make the condition true. Now let's make it equals 2. X is even. Now let's recap. Lesson 06 hyphen if. So today we learn about the if, elif, else statement, the nested if, and the ternary operator. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about lists, which are very useful because they can contain elements of different types. Let's get started. Let's create the file lesson 07 hyphen list.py. First underscore list equals square brackets 0, 1. Print first underscore list and run it. And this is our first list. Now let's print the type 2. Print parenthesis type parenthesis first underscore list and run. As you can see, it's a list, and as I said, can contain many different types. Let's try it. Comma 0.9, comma true, comma quotation mark string, comma square brackets. That's an empty list. And run. Here it is. You can access an element of a list by using indexing. The first element of a list is at index 0, the second at index 1, and so on. So, print parentheses first underscore list square brackets 0 and run it. Now let's try to access the last element of a list. Print parentheses first underscore list square bracket 5 and run it. 0 and empty list. There is another way to access the last element of a list. It's using negative index. -1 represents the last element of a list. Let's try it. Comma, first underscore list, square brackets, -1, and run. And as you can see, we get the last element twice. We can use a positive or negative index, it's the same. So if we want the first number, we have to use the -6 index. Let's try it. Comma, first underscore list, square bracket, -6. We can even select just a part of the entire list using the slicing syntax. Let's do it. Print parentheses first underscore list square bracket 0:4 and run. And as you can see, we get the first, the second, the third, and the fourth element of the list. Now let's create a new list. Numbers equal square bracket 10, 11, 12 and print it. Now let's add a new element to this list. Numbers dot append parentheses 13 and print. Now let's add a new element between the first and the second element of our list. Numbers dot insert parentheses 1, 14. Print parentheses numbers and run. Now let's remove the first element of our list. Numbers dot pop parentheses 0. Print parentheses numbers and run. Now let's remove an element we know is in the list. Numbers dot remove parentheses 11. Print parentheses numbers and run. Now let's reverse the order of the elements of our list. Numbers dot reverse parentheses print parentheses numbers. Now let's sort our list. Numbers dot sort parentheses print parentheses numbers. Now let's copy our list. N equals numbers dot copy parentheses print parentheses n. Now let's extend our list with this list we just created. Numbers dot extend parentheses n. Print parentheses numbers and run. And now let's clear our list. Numbers dot clear parentheses print parentheses numbers and run. Let's print n2 comma n and run. So we learned a lot in this lesson. Let's recap. Lesson 07 hyphen list. We learn about list. We learn how to select elements. And we learned many methods that help us manipulate lists. Append, insert, pop, remove, reverse, sort, copy, extend, clear. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about the for loop. A for loop is a way to iterate a block of code a specific number of times, eliminating the need to write the same code repeatedly. Let's try it. Lesson 08 hyphen for.py. Let's create a list. Numbers equals square brackets 0, 1, 2, 3 and print it. Print parentheses numbers and run. So far so good. Now let's create our first for loop. For n in numbers, colon, new line, print, parentheses, n, and run it. It's as if we are creating a variable n that will take on the value of each element in the list, numbers, starting from the first element. So in the first iteration we get printed 0, then 1, then 2, until the last element, which is 3. Another way you'll find for loop is with the range function, which creates an iterable data structure that we can use similarly to how we did with the list. Let's try. New line, remove the indentation. For I in range, parentheses, 10. Close parentheses, colon, print I and run it. As you can see, we obtain all the numbers from 0 to 10, excluding 10. Let's create a string. My underscore name equals quotation mark red. And I want to print just the first letter. Print, parentheses, my underscore name, square brackets, 0. And run. And we obtain just the R. That's because we can also iterate through a string as we did with the list. But can we use the range function to get the same result? To do it, we need to know the length of the string. So print parenthesis len parenthesis my underscore name. And if you run it, you can see the length of your string, that is 3 in our case. So let's put the len function inside the range function, specifying how many times it has to iterate. For I in range parenthesis len parenthesis my underscore name, because the parenthesis colon print parenthesis my underscore name square brackets I, and run it. And we obtain my name printed letter by letter. Now let's create a matrix using a nested for loop. Matrix equals square brackets new line for I in range parenthesis 1, 3 close the parenthesis colon. In this way we are telling the range function to start with 1 instead 0. For j in range parenthesis 4 close the parenthesis colon. New line pair equals square bracket I comma j. New line matrix dot append parenthesis pair, and then print parenthesis quotation mark I equals quotation mark comma I comma quotation mark j equals quotation mark comma j. Close the parenthesis, remove the indentation, and print parenthesis matrix. Close the parenthesis and run. Now we can see all the values assumed in the iteration by our two indexes I and j. Now, what can we do if we want to interrupt the iteration until something happens? We can use the break keyword. Let's try it. For I in range parenthesis 10 colon new line if I bigger than 7 colon break new line print parenthesis I. All the number between 0 to 7 has been printed. I bigger than 7 becomes true with I equals to 8, triggering the execution of the break keyword. Now let's modify 10 to 5 so that we don't trigger the if condition. And let's add else colon new line print parenthesis quotation mark the loop is finished, and run it. As you can see, the values from 0 to 4 has been printed, and since the loop completed without any interruption, also the message the loop is finished has been printed. Now let's try to make the range bigger. Let's try 50 and run. So in this case, the condition I bigger than 7 become true when I is equal to 8. This interrupts the for loop without executing the block of code inside the else statement. We learned a lot for this lesson. Let's recap. Lesson 08-4. Learn about for, else, len function, range function, and how to break a loop. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about how to import new modules into your program so you can use many other functions. Let's get started. First, create the file lesson 09-import.py. Let's import our first module, import OS, which lets us interact with our operating system. And let's use a function from that module. CWD equals os dot get CWD, parenthesis, new line, print, parenthesis, CWD, and run. As you can see, with this function we can obtain the current working directory. Files equals os.listdir, parenthesis, new line, print, parenthesis, files, and run. With this second function we obtain all the files inside our current working directory. Let's use another function, os.system, parenthesis, quotation mark, cls, pipe, clear, and run. With this command you can delete what's in the terminal, which is why it's empty. Now let's import just a single function from a module. From random import randint. For I in range, parenthesis, 10, colon, new line, print, parenthesis, randint, parenthesis, 1, 10. With this line we are asking for a random number from 1 to 10. Run, and we got them. Now let's import another function from datetime, import datetime as dt. The as is useful to rename the function. So time equals dt, parenthesis, 2022, 6, 1, 2, 3, 4, and print it. Print, parenthesis, time. Run it. As you can see, we obtain a date. Now let's import another function from datetime, import time delta. Print, parenthesis, time plus time delta, parenthesis, 2. In this way, we are adding 2 days to the time variable. Let's see. Now let's import another module. Import math as empty. Print parenthesis empty that costs parenthesis 3.14, almost pi, and we obtain minus 0.99. For this lesson it's enough. Let's recap. Lesson 09-import. We learned about how to import just a function with from, and how to rename a function. And we learn about us, random, datetime, and the math module. For this lesson it's enough. Thanks for watching. See you in the next lesson. In this lesson we are going to create a very basic version of Tic-Tac-Toe using almost everything we learned till now. Let's create the file. Lesson 10 hyphen tic hyphen tac hyphen toe.py. First, we have to create the board. Board equals quotation mark, quotation mark, quotation mark, new line, space 1, space hash, space 2, space hash, space 3, space, new line, all hash, new line, space 4, space, hash space 5 space hash space 6, new line, again all hash, new line, space 7 space hash space 8 space hash space 9 space. This is the board. Now let's create the players. Player underscore x equals empty list. Player underscore o equals empty list. Now let's create the interaction between the players and the board. For I in range parenthesis 9 colon print parenthesis board if I module 2 equals 0 colon player x dot append parenthesis input parenthesis select a number colon space a new line board equals board dot replace parenthesis player x square bracket -1 the last element comma quotation mark x, else the second player. So let's copy and paste and replace any x with an O. One, two, and 3. Let's try. One, it works. Two, and it works. Control C to interrupt. Now, let's create the winning combinations. Winning underscore combinations equals square brackets 1, 2, 3, close, comma, square brackets 4, 5, 6, close, comma, square brackets 7, 8, 9, close, comma, square brackets 1, 4, 7, close, comma, square brackets 2, 5, 8, close, comma, square brackets 3, 6, 9, close, comma, square brackets 1, 5, 9, close, comma, square brackets 3, 5, 7. Now, for combination in winning underscore combinations, colon, for j in range, parenthesis 3, colon, if str function combination square bracket j in player x, colon, we need to count equals 0, count plus equal 1. That's the same as count equals count plus 1. If count equals 3, colon, the player has won, but we need a Boolean to change when the player won. So player underscore x underscore 1 equals false. Player underscore o underscore 1 equals false. So if count equals 3, player underscore x underscore 1 equals true. Let's print parentheses, quotation marks, player x 1. Break. If player underscore x underscore 1 colon break, so the game ends. Let's try. One, 4, 2, 5, 3. Player x1. Perfect. Now let's make it nicer. From OS import system. System, parenthesis, quotation mark, CLS, pipe, clear. Let's copy. And paste here. Print, parenthesis, board. Let's try. 1, 2, 3, 4, 5, 6, 9. Okay. Let's copy everything and replace the X with the O everywhere. Copy, paste. One, 2, 3, and 4. Let's try. 1, 2, 3, 5, 6, 8, player 0, 1. Perfect. And now let's handle the draw scenario, which occurs when the main loop finishes without either player winning. Else system, parenthesis, quotation mark, CLS, pipe, clear. Print, parenthesis, board, print, it's a draw. Let's try again. One, 2, 3, 4, 5, 6, 8, 9, 7. Player x1. Let's make a draw. 1, 2, 3, 5, 4, 6, 8, 7, 9. Perfect, it's a draw. Let's make the player O win. 1, 7, 2, 8, 4, 3, 5, 9. Player 01. That's it for today. Let's make a title for this program. Lesson 10 hyphen Tic-Tac-Toe. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson, we are going to talk about a new type that is very similar to a list, the tuple. Let's create the file lesson 11 tuple.py. T equals parentheses 10, 20, 30. New line, print, parentheses, type, parentheses, t. Close the parentheses, comma, t, and run it. And as you can see, the type is tuple. Now let's create another tuple. T1 equals 11, 12, 13, 14. New line, print, parentheses, type, T1, close the parenthesis, comma, T1. So when we create a tuple, the comma is the fundamental part that defines the tuple. Let's try to create two other tuples. T2 equals parentheses 9. New line, T3 equals parentheses 9, comma. New line, print, parentheses, type, parentheses, T2, close the parentheses, comma, T2. New line, print, parentheses, type, parentheses, T3, close the parentheses, comma, T3, and run it. As you can see, the 9 without the comma is considered an integer. It's not a tuple. So tuples are immutable collections of elements, meaning we cannot add, remove, or modify any of their elements. Due to this immutability, tuples are faster and occupy less space compared to lists. This becomes particularly important when dealing with numerous collections. Now, let's try a multiple assignment. A, B, C, D equals T1. New line, print, parentheses, A, B, C, D, and run it. As you can see, we assigned every element of T1 to a different variable. Now let's try to access every element of a tuple using two ways we already know. For item in C, column, new line, print, parentheses, item. And for I in range, parentheses, len, T1, close the parentheses, column, new line, print, parentheses, T1, square brackets, I, and run it. As we would have done with a list, we accessed every element of these two tuples. Now let's recap. Triple quotation mark, lesson 11 tuple. So in this lesson we learned a lot about this new type, the tuple. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about the while loop that is very similar to the for loop. Let's get started. Lesson 12 while.py. Count equals 0. New line, while count less than 10, column, new line, print, parentheses, count. New line, count, plus equal 1. That is the same as count equals count plus 1. And run it. As you can see, we obtain the same as we would have using a for loop like this. For I in range, parenthesis, 10. Else, colon, new line, print, parenthesis, quotation mark, count equals 10, and run. As in a for loop, the while loop can also be used with the else statement in the same way as we just did. Now, let's create another while loop. Count equals 0, new line, while true, column, new line, print, parenthesis, count, new line, count plus equal 1. If count double equals 10, column, new line, break, remove the indentation, else, column, new line, print, parenthesis, quotation mark, unusable, and run. In this case, the while loop ended because of the break statement inside it, as we have already seen with the for loop. Let's create another while loop. Count equals 0, new line, while count less than 10, column, new line, count plus equal 1, new line, if count double equals 5, column, new line, continue, new line, print, parenthesis, count, and run. In this case, the number 5 hasn't been printed due to the continue statement. The continue statement prevents the execution of any code following it within a loop once it's executed. Let's recap. Lesson 12-while. We learned about while, else, and we learned about the continue statement. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about dictionary, an unordered collection of key value pairs. Let's get started. Lesson 13 hyphen dictionary.py. Lessons equals curly brackets, quotation mark, lesson 01, quotation mark, column, quotation mark, string, quotation mark, comma, quotation mark, lesson 02, quotation mark, column, quotation mark, variable, quotation mark, and print it. Print, parenthesis, type, parenthesis, lessons, comma, lessons. and run it. As you can see, is a dict type. We created a dictionary of 2 keys and 2 values. The keys are lesson 01 and lesson 02. The values are string and variable. Print, parentheses, lessons, square brackets, quotation mark, lesson 01, and run it. As you can see, in the dictionary you get the values using the keys, which is why a key must be unique. You can also print all the keys and all the values. Let's do it. Print, parentheses, lessons, dot, keys, parentheses. New line, print, parentheses, lessons, dot, values, parentheses. And run it. The keys and the values. Now let's add a new pair. Lessons, square brackets, quotation mark, lesson 03, quotation mark, close the square bracket, equals, quotation mark, integer. New line, print, lessons, and run it. And the new pair has been added. Now let's iterate through the dictionary. For key in lessons, column, new line, print, parentheses, quotation mark, key, equals, quotation mark, comma, key, comma, quotation mark, space, value, equals, quotation mark, comma, lessons, square bracket, key, and run it. So a dictionary is as iterable as a string, as a list. Now let's try to delete a pair. Del, lessons, square brackets, quotation mark, lesson 03, and print it. For I in range, parentheses, len, parentheses, lessons, column, new line, print, parentheses, list, parentheses, lesson dot values, parentheses, close the parentheses, square brackets, I, and run it. As you can see, in this way you printed just the values. Now let's recap. Lesson 13 hyphen dictionary. We learn about dictionary. We learn about keys, values, and we learn about the list function. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we're going to talk about the try statement that's used to manage errors that otherwise would interrupt the program. Let's get started. Let's create the file lesson 14 hyphen try.py. Try column new line print parentheses 10 divided by 0 except column pass. New line, remove the indentation, print, parenthesis, quotation mark, program terminated, and run. So what's happened? The try statement marks the beginning of the try block. In the second line, we attempt to print 10 divided by 0. It results in a 0 division error, which triggered the except block, which contained the pass statement that is a no operation statement in Python. In this way, we have been able to print the last line. Now let's try to print the error. Exception as E. New line, print, parenthesis, E. Let's comment pass and run. Division by 0, and then printed again. Program terminated. Let's try something else. Try, column, new line, I equals input, parenthesis, quotation mark, insert a number, column, space, new line. I equals int, parenthesis, I. New line, print, parenthesis, I. Except value error, column, new line, print, parenthesis, I, comma, quotation mark, is not a number, and run. And let's insert A. A is not a number. Let's run again. Let's insert 0. And it works. We can use as many except as we want. So let's try. Print, parenthesis, 10 divided I. Except 0 division error, column, new line, print, parenthesis, quotation mark, I can't be 0, and run. In this way, we are able to control what the user input when interact with the program. Let's insert 0. Let's run again. Now let's insert 1. Now let's use the else statement. Else, column, new line, print, parenthesis, quotation mark, I, print, if there aren't errors. And then let's add the finally statement. Finally, column, new line, print, parenthesis, quotation mark, I, print, always, and run. Let's insert A. A is not a number. I print always. Let's insert a number. 10. I print if there aren't errors. I print always. Perfect. Now let's recap. Lesson 14 hyphen try. We learned about the try, the except, the else, and the final statements, and we learn about the pass statement. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to learn how to create functions, similar to the ones we've used up until now. Let's get started. Lesson 15 hyphen function.py. To create a function you have to use the def statement. So def my underscore function parenthesis column new line print parenthesis quotation mark hello world. And run. And as you can see, nothing is in the terminal, which is why we have to call the function. So let's call it my underscore function parenthesis and run. And there it is. Hello world. Now let's create another function. Def greet parenthesis name column new line print parenthesis quotation mark hello comma name. Let's call it greet parenthesis quotation mark red and run it. And as you can see, we pass a variable red to the function and it's then used inside the function. It's like we are assigning the string red to the variable name. We can also assign a default value to a parameter in a function, which will be used if we don't provide a value when we call the function. So name equals quotation mark world. Now let's call without the parameter greet parenthesis and run. And as you can see, we get hello world. Let's create another function. Def add parenthesis a comma b equals 3 column new line return a plus b. The return statement will return as a value, the sum between a and b. Let's assign this value to a variable number equals add parenthesis 2 new line print parenthesis number and run it. And as you can see, we get 5. Now let's discover another way to call many parameters using the asterisk. This is a concept you'll see more in an intermediate level, but you can see also in a basic level. Def add underscore args parenthesis asterisk args close the parenthesis column new line result equals 0 new line for n in args column new line result plus equal n new line return result. In this way we can pass as many numbers as we want, and in return we will receive the sum of all of them. Print parenthesis add underscore args parenthesis 1, 2, 3, 4, 5, 6 and run it. and the sum of all of them is 21. Now let's recap. Triple quotation mark, lesson 15 hyphen function. We learned how to create a function. We learned how to return something from a function. And we learned how to handle an unknown number of parameters. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to learn how to read and write files. Let's get started. Lesson 16 hyphen read and write .py. There are two ways to read and write files. Let's start with the older method. File equals open parenthesis quotation mark, the name of the file, in this case lesson 01 hyphen string.py, quotation mark, comma, quotation mark, new line, content equals file dot read parenthesis, new line, print parenthesis content, new line, file dot close parenthesis and run. As you can see, we printed everything we wrote in the file. Now let's explore the alternative method, which is also considered the best practice for working with files, with open parenthesis quotation mark, name of the file, lesson 02 hyphen variable.py, quotation mark, comma, quotation mark, r, as file, column, new line, content equals file dot read parenthesis, new line, print parenthesis content and run. And we read also the second file. Now let's write into a file with open parenthesis, name of the file again, quotation mark, output.txt, quotation mark, comma, quotation mark, w, quotation mark, parenthesis, as file, column, new line, file dot write parenthesis, quotation mark, first line, backslash n, new line, file dot write parenthesis, quotation mark, second line. Now let's read it with open parenthesis, quotation mark, output.txt, quotation mark, comma, quotation mark, r, quotation mark, close parenthesis, as file, column, new line, print, file.read, and run. And as you can see, first line, second line. Let's open the file. There it is. Now let's add a new line into the file we just created with open parenthesis, quotation mark, output.txt, quotation mark, comma, quotation mark, a, quotation mark, parenthesis, as file, column, new line, file dot write, parenthesis, quotation mark, second line, new line, with open parenthesis, quotation mark, output.txt, quotation mark, comma, quotation mark, r, quotation mark, parenthesis, as file, column, new line, print, parenthesis, file, dot read, and run it. As you can see, we obtain again second line. Let's open the file to see, and that's correct. Now let's eliminate the file. Import OS dot remove parenthesis, quotation mark, output dot txt, and run. And we removed the file. Let's recap. Triple quotation mark, lesson 16 hyphen read and write. We learned how to open a file in two ways. Open with as. We learn how to use the read function, the write function, and the remove function. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to explore a crucial topic that you need to understand because it's widely used: list comprehension, which is a concise way to create lists in Python. Let's get started. Lesson 17 hyphen list comprehension .py. Numbers equals square brackets x for x in range parenthesis 5. Let's print parenthesis numbers and run. And as you can see, we created a list from 0 to 4 using a for loop. Let's create another list. Squares equal square brackets x double asterisk 2 for x in range parenthesis 5. New line, print parenthesis squares and run. And as you can see, we get all the numbers from 0 to 4 raised to the power of 2. Double underscore even equals square brackets x multiplied by 2 for x in numbers if x module 2 double equals 0. New line, print parenthesis double underscore even and run. And as you can see, we get the even numbers from 0 to 4 multiplied by 2. That's because with the if statement we check if the numbers in the list are even, and if they are, we multiply them by 2. Now let's create a matrix. Matrix equals square brackets numbers for x in range parentheses 3. New line, print, parentheses, matrix. And as you can see, we obtain a matrix with 3 lists from 0 to 4. Now let's recreate the same list showing the nested list comprehension. Matrix 2 equals square brackets x for x in range parentheses 5. Close the parentheses, close the square bracket for y in range parentheses 3. New line, print, parentheses, matrix 2. And we obtain the same result as before. Let's recap. Triple quotation mark, lesson 17 hyphen list comprehension. In this lesson, we learned about this comprehension. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson, we are going to talk about a concise way to create functions using the Lambda keyword. Let's get started. Lesson 18 hyphen Lambda function .py. Add equals Lambda x colon x plus 1. New line, print, parentheses, add, parentheses, 3, and run. As you can see, the variable add behaves like a function. So, Lambda functions are used when you need a quick function without formally defining a full function using the def keyword. Let's create another Lambda function. Add underscore numbers equal Lambda x comma y column x plus y. New line, print, parentheses, add underscore numbers, parentheses, 4, 5, and run. And we get 9. Let's create a list, letters equal, square bracket, quotation mark, for y, quotation mark, comma, quotation mark, 3z, quotation mark, comma, quotation mark, 5a, quotation mark, comma, quotation mark, 6x, quotation mark, comma, quotation mark, 6w. A new line. Print, parentheses, letters. New line, letters, dot, sort, parentheses, key, equals, lambda, x, column, len, parentheses, x. New line, print, parentheses, letters. And run. As you can see, By using the lambda function inside the sort function, we managed to sort the strings by their length instead of alphabetically. Now let's create a function, def add underscore 1, parenthesis, n, close the parenthesis, column, new line, return lambda x, column, x plus n, new line, number equal, add underscore 1, parenthesis, 20, new line, print, parenthesis, number, parenthesis, 1, and run it. In this way, we assigned the lambda function with n equals 20 to the variable number, and then we print the result of the variable number with the parameter 1. Now let's recap. Triple quotation mark, lesson 18 hyphen lambda function, where we learn about lambda functions and how to use the k inside the sort function. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson I'm going to talk about a recently introduced feature in Python, the match statement. Let's create the file. Lesson 19 hyphen match.py. Command equals input parenthesis quotation mark, choose a greeting, column space, new line, match, command, column, new line, case, quotation mark, 1, column, new line, print, parenthesis, quotation mark, hi, new line, case, quotation mark, 2, column, new line, print, parenthesis, quotation mark, hello, new line, case, underscore, column, new line, print, parenthesis, quotation mark, invalid choice, and run it. The match statement compares the command with each of the case statements. Let's try. 1, and we get high. Run again. 2, and we get low. The underscore is used as the default and is executed if none of the other cases match. Let's try. 3, invalid choice. Now, let's create a new variable, item equals 2. Match item, column, new line, case, int, parenthesis, x. If x greater than 0, column, new line, print, parenthesis, item is a positive number, quotation mark, comma, x, new line, case, str, parenthesis, x, column, new line, print parenthesis quotation mark item is a string, quotation mark column x. Case list parenthesis x column new line print parenthesis quotation mark item is a list, quotation mark comma x, and run it. First, let's analyze it. To match the first case, the item must be an integer greater than 0. To match the second case, the item must be a string. To match the third case, the item must be a list. Let's try. Let's choose the greeting. 1. Item is a positive number because it's 2. Let's change it. -2. And run it. Choose a greeting again. 2. We didn't obtain anything because the item doesn't match any of the cases. Now let's make it a string and run it. Three. Item is a string -2. Let's make it a list and run it. Four. Item is a list. Let's recap. Triple quotation mark. Lesson 19 hyphen match. We learned about the match case and how to use it. So, for this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to create Snake, the game. Let's create the file lesson 20 snake.py. Let's make some import useful for our program. Import os new line, import time new line, import random new line, import msv crt. And let's create some constants. Board underscore width equal 20. Board underscore 8 equal 5. Difficulty equal 8. Let's create the main function. Def main parenthesis column. Let's create the main loop while true column new line. And let's create the draw function, which will take care of draw everything at any loop simulating the movement. So let's create the head of the snake. Head underscore position equals square brackets board underscore width double slash 2 comma board underscore height double slash 2, and that will be the starting point. Let's create the tail underscore positions equals square brackets head underscore position dot copy. Now let's create the fruit. Fruit underscore position equal create underscore fruit parentheses tail positions. Let's create this function def create underscore fruit parentheses tail underscore positions column new line fruit underscore position equal square brackets random dot randint parentheses 1 comma board underscore width close the parentheses comma random dot randint parentheses 1 comma board underscore height, and this position can be one of the tail positions, so we have to check for this. Let's copy this line and then while fruit underscore position in tail underscore positions column new line, and let's paste here new line return fruit underscore position. In this way the fruit should always appear in an empty position. Now let's create also the draw function def draw parentheses fruit underscore position comma head underscore position comma tail underscore positions column new line, and let's create the board equal create underscore board parentheses fruit underscore position comma head underscore position comma tail underscore position, and let's create this function def create underscore board parentheses fruit underscore position comma head underscore position comma tail underscore position column new line board equals empty string new line, and let's create two loops for I in range parentheses board underscore height plus 2 because we have to consider also the thickness of the board column new line for j in range parentheses board underscore width plus 2 column new line if I double equals 0 or j double equals 0 or I double equals board underscore height plus 1 or j double equals board underscore width plus 1 column new line board plus equal quotation mark hash, which will be the perimeter of our board. If fruit underscore position double equals square brackets j comma I column new line board plus equal quotation marks f. This will be the fruit new line if head underscore position double equals square brackets j comma I column new line board plus equal quotation marks o. If square brackets j comma I in tail positions column new line board plus equal quotation marks o new line else column new line board plus equal quotation marks space new line board plus equal quotation mark backslash n new line return board. So this function converts the position of any object into a graphical representation, which we are going to call any loop of the main loop after clearing the terminal. Let's do it. os.system parentheses quotation mark cls new line, print, parenthesis, board. And let's also update the tail positions, removing the first element and appending the head position. In this way, the tail positions array will always contain the position of any part of the snake. Tail underscore positions dot pop parenthesis 0. Tail underscore position dot append parenthesis head underscore position dot copy parenthesis. Now let's add all these to the draw function. Fruit underscore position, comma, head underscore position, comma, tail underscore positions. And let's add time dot sleep parenthesis 1 / difficulty. So higher the difficulty, quicker the snake. Let's call the main function main parenthesis, and let's try to run it. As you can see, it doesn't move because we had to create the function, and we have to manage the directions, which means to keep track of the current direction of the snake. So we are going to create a dictionary with 3 directions set as false and 1 direction set as true. Directions equal curly brackets, quotation marks, right, quotation marks, column, true, comma, quotation marks, left, quotation mark, column, false, comma, quotation marks, up, quotation mark, column, false, comma, quotation marks, down, quotation mark, column, false. And let's update the head position. Head position equal move parenthesis head underscore position, comma, directions. Let's create this function. Def move parenthesis head underscore position, comma, directions. First we have to get the key. Column, new line, key equal get underscore pressed underscore key parenthesis. And let's create this function. Def get underscore pressed underscore key column new line if msv crt dot kb hit parenthesis column return msv crt dot get ch parenthesis dot decode parenthesis new line else column return empty string. Now let's go back to our move function. If key double equals quotation marks d quotation mark column new line head underscore position square brackets 0 plus equal 1 and directions square brackets quotation marks right equals true. Else if key double equals quotation marks a quotation marks column new line head position square brackets 0 minus equal 1 new line directions square brackets quotation mark left equals true. We have to set all the time the direction as true. Else if key double equals quotation marks s quotation mark column new line head position square brackets 1 plus equal 1. Directions square brackets quotation marks down equals true. New line elif key double equals quotation marks w column new line head underscore position square brackets 1 minus equal 1 and set the direction as true. Directions square brackets quotation marks up equals true. Else we have to manage the case when none of those has been pushed. Else if directions square brackets quotation marks right quotation marks square brackets double equals true. Head underscore position square brackets 0 plus equal 1. If directions square brackets quotation marks left double equals true column new line head underscore position square brackets 0 minus equal 1. Now vertically if directions square brackets quotation marks down double equals true column new line head underscore position square brackets 1 plus equal 1. New line if directions square brackets quotation marks up double equals true new line head underscore position square brackets 1 minus equal 1. Now with a notice we have also to set the perpendicular directions to false. So let's do it. Directions square brackets quotation marks up equal false. Let's copy and paste this line, paste, down, let's copy them in the other elif, paste here and let's change left, right, let's copy, and let's paste here, and so everything should be work perfectly. And we have also to manage it when we touch the perimeter. So head underscore position equal change underscore side parenthesis head underscore position, and let's already return the head underscore position. Return head underscore position. Now let's create the function. Def change underscore side parenthesis head underscore position column new line if head underscore position square bracket 0 double equals 0 column new line head underscore position square brackets 0 equal bore underscore width. In this way, when we touch the side of the board, the head will be sent in the other side of the board. If head underscore position square brackets 0 double equals bore underscore width plus 1 column new line head underscore position 0 equal 1. And that's the same for the vertical position. So let's copy and let's paste. The zeros becomes 1, and we have to switch board width with board height. Let's return the head position, and that's it. I think we can run it. Let's try it. Let's move this around. It goes down. Okay, it goes down. We have to manage the interaction with the fluid, and it can't go back in the same direction. We have to manage also this thing. So let's do this thing. So if k double equals quotation marks the and directions square brackets quotation marks left quotation marks double equals false. Let's do it for the others. And direction square brackets quotation marks right quotation marks double equal false, and directions square brackets quotation marks up quotation marks double equals false, and directions square brackets quotation marks down double equals false. And so that should be okay. Now I had to create the interaction with the fluid and with itself also. So if head underscore position in tail underscore positions column new line break, and if head underscore position double equals fluid underscore position column new line tail underscore position dot append parenthesis head underscore position dot copy parenthesis fluid underscore position equals create underscore fluid parenthesis tail underscore positions, and I can create also the score. So let's create the score variable score equals 0, and let's increment it score plus equal 9. I think it's everything now. Should work perfectly. Let's print the score. So comma score comma score new line print parenthesis quotation marks score column comma score, and I think that's it. Let's run it and let's try it. Let's try to take this fruit. It works. Let's try again. All in the same line. Cool. Let's try to get this fruit too. And then we can also try to die. Okay. I think it's been a good lesson. We did a lot. So let's recap. Lesson 20 - snake. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about f-strings, which are a very common way to manipulate strings in order to print them. Let's get started. First, let's create the file lesson 21 f-string.py. Let's create a variable s equal quotation mark Python, quotation mark, new line, print, parenthesis, and now f quotation mark, curly brackets, s, and run. And as you can see, just the variable has been printed, just what's inside the quotation marks. Let's try to format our string s.title, parenthesis, and run. And the first letter should be uppercase. As you can see, it is. Now, let's try to create two other variables, and 1 equals 1 and 2 equals 2, print, parenthesis, f, quotation mark, curly brackets, and 1, close the bracket, plus, curly brackets, and 2 equals, curly brackets, and 1 plus and 2, and run. One plus 2 equals 3. So we can insert all the expressions we want inside the curly brackets. Now, let's try to insert a float. Pi equals 3.14159265, and let's print it. Print, parenthesis, f, quotation mark, pi equals, curly brackets, pi, colon, dot, 2f, and run. As you can see, with this little format, we printed just the first 2 decimals. Now, let's try to print using the double quotation mark, print, parenthesis, f, double quotation mark, and 1 equals, curly brackets, and 1, colon, 010d, and run. In this case, we formatted our variable so that n leading zeros ensure a total width of 10 characters. Another common problem when we use quotation marks is how to use quotation marks inside the quotation marks. Let's explore one solution. Print, parenthesis, f, quotation mark, curly brackets, s dot replace, parenthesis, double quotation mark, p, comma, double quotation mark, p in uppercase, and close the parenthesis, and run. And as you can see, we have been able to use the double quotation marks inside the quotation mark, as we always did. And now let's try to print multi-line using f-strings. Let's try 2 ways. Backslash n, quotation mark, backslash f, quotation mark, it, backslash, quotation mark, s, curly brackets, s, and run. As you can see, as we did with the normal string, we printed a quotation mark inside quotation marks using backslash. And we use the backslash also to make our code more compact, which is very important, especially when you deal with very long strings. Now let's try another way to print multi-line using f-strings. Print parentheses f 6 quotation marks. Now between the 6 quotation marks, curly brackets, s dot replace parentheses quotation mark p quotation mark comma quotation mark p in uppercase and new line. It's curly brackets s. So using f-strings might be a bit uncomfortable when you start to use it, but it's used really a lot. You'll see it in a lot of code, so you needed to know, and now you do. So let's recap. Lesson 21 hyphen f hyphen string. We learn about f-string. We learn about the title function. We learned about the replace function. And we learned two nice ways to format our variables. .2f and 010d. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about a new type, the set type. A set is a collection of distinct elements with no specific order. Let's create the file lesson 22 hyphen set.py. Let's create our first set as equal curly brackets 1, 3, 2, 4, 5, 5, 5. And let's print it. Print parentheses type s, s and run it. As you can see, we printed our first set, which contains all the numbers we inserted in ascending order without repetitions. This is a set. Now let's try to print an empty set. Empty equal set parentheses new line print type parentheses empty comma empty and run it. So this is how we can create an empty set. Now let's create another set with different types inside. S1 equal curly bracket quotation mark a quotation mark comma true comma 2 comma 3.14, and let's print it. Print parentheses S1. Now let's try to access one element of a set. Try column new line print parentheses s square brackets 0 new line except print parentheses you cannot access values by index. and run. As you can see, we can't, but we can check if an element is in the set. Let's try. If 1 in s column, new line, print, parenthesis, quotation mark, 1 is present, and run. So, this is the way to check if an element is in a set. Now, let's try to iterate through a set. For element in s column, new line, print, parenthesis, element. Now, let's try to convert a list into a set. Let's create a list. L equal square bracket 1, 2, 1, 2, 1, 1, 3, 3, 3. And let's print this list as a set using the set function. Print, parenthesis, set, parenthesis, L, and run it. As you can see, we obtain a set from the list. Now let's try some of the most common methods of a set. S dot add, parenthesis, 6, print, parenthesis, s, and run it. Now let's try to add 6 again to see what happened. Let's copy and paste these 2 lines. As you can see, if you try to add an element that's already in a set, nothing happens. Now let's try to remove an element. S dot remove, parenthesis, 6. Print, parenthesis, s, and run it. So, we removed 6. Now, let's try another way to remove an element, which is very useful if we don't know if the element is in the set. S dot discard, parenthesis, 5. New line, print, parenthesis, s, and run it. Now let's copy a set. S2 equals s dot copy, parenthesis, new line, print, parenthesis, s2, and run it. As you can see, we copied our set as we did for lists. Now let's try some set-specific method. Print, parenthesis, s1 dot intersection, parenthesis, s, and run. The intersection between 2 sets returns the elements that are common to both sets. In this case, the Boolean element true is converted to 1, which is why the intersection returns 1 and 2. Let's try another one. Print, parenthesis, s1 dot union, parenthesis, s, and run. In this case, we obtain the union between the 2 sets. Let's try the last one. Print, parenthesis, s1 dot difference, parenthesis, s, and run. Clearly, we obtain the difference in this case. Now let's recap. lesson 22 hyphen set. We learned about the set type. We learned about the set function. And we learned many specific set methods. Add, remove, discard, copy, intersection, difference, union. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about a new type, the Frozenset, which is very similar to the set type except it's immutable. So let's create the file. Lesson 23 hyphen Frozenset .py fs equals Frozenset parentheses square brackets 1, 3, 2 and print it. Print parentheses type parentheses fs fs and run it. So we printed our first Frozenset, which is symbolized with curly brackets instead of the square brackets we used. Unlike for the set, the numbers are in ascending order. Let's create another Frozenset using a different bracket. fs1 equal Frozenset parentheses 2, 4, 3, 6, 5 and print it. Print parentheses type parentheses fs1, fs1 and run it. Also in this case the parentheses have been replaced with curly brackets. That's because to create a Frozenset we used the Frozenset function, which takes an iterable and returns a Frozenset that is an unordered, immutable set of unique elements. Let's try something else. S equal curly brackets 1, 3, 2, 6. New line. fs2 equals Frozenset parentheses s and print it. Print parentheses type parentheses fs2, fs2 and run. As you can see, we created our third Frozenset. Now let's try some methods. Print parentheses fs dot union parentheses fs1 and run. Okay, let's try another one. Print parentheses fs dot intersection parentheses fs2 and run it. Let's try another one. Print parentheses fs dot difference parentheses s and run it. So those are the same method used in the last lesson. Let's try something new. Print parentheses fs dot symmetric difference parentheses fs1 and run. The symmetric difference returns the set of elements that are unique to each Frozenset. Let's try another one. Print parentheses fs dot is subset parentheses fs2 and run it. This method returns true if all elements of the first set are present in the second set. Let's try the opposite. Print parenthesis fs dot is superset parenthesis fs2 and run it. Now let's create another Frozenset. fs3 equals Frozenset parenthesis curly brackets 3, 2, 1. New line, print parenthesis fs3 double equals fs and run it. As you can see, we get true. That's because they represent the same set of elements. Now let's try to iterate through a Frozenset for element in fs3 column new line print parenthesis element and run. Now let's recap. Lesson 23 hyphen Frozenset. We learn about the Frozenset type. We learned about the Frozenset function, and we learn many methods: union, intersection, difference, symmetric difference, is subset, and is superset. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about Enumerate, a function which is very useful when you need to use the index and the value of an iterable, like a string or a list. Let's create the file. Lesson 24 hyphen enumerate.py. Let's create a variable s equal quotation mark Python quotation mark new line for index comma element in enumerate parenthesis s column new line print parenthesis f quotation mark index equal curly brackets index comma element equals curly brackets element. Using enumerate in a for loop is very similar to write both for index in range parenthesis lam parenthesis s and for element in s. Let's run it. So, using enumerate in a for loop makes the code more clean and readable. Now, I know that using enumerate may seem unnecessarily complex, but it's just a matter of getting used to it. Now let's try to create a list. L equals square brackets quotation mark A quotation mark comma quotation mark B quotation mark comma quotation mark C quotation mark comma quotation mark D. New line for index comma element in enumerate parenthesis L comma start equal 3. In this way the index will start from 3 instead 0. Print parenthesis f quotation mark index equal curly brackets index comma element equal curly brackets element, and run it. As you can see, index equals 3, element equals a, and so on. Now let's make also the list. Start from the third element. Square brackets 3 colon, and run it. In this way we can easily use just part of a list. Now let's try to use a dictionary. D equals curly brackets quotation mark a quotation mark column 1 comma quotation mark b quotation mark column 2 comma quotation mark c quotation mark column 3. Let's create a loop for index comma parenthesis k comma value close the parenthesis in enumerate parenthesis d dot items parenthesis column new line print parenthesis f quotation mark index equal curly brackets index comma key equals curly brackets key comma value equals curly brackets value, and run it. And as you can see, we obtain in the cleanest way the index, the key, and the value. Now let's recap. Lesson 24 enumerate. We learned about the enumerate function and how to use it. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to discuss some practice you might encounter when using the for loop. Let's create the file. Lesson 25 more for loop uses .py. Now let's create a for loop for underscore in range parenthesis 2 column new line print parenthesis quotation marks hello, and run it. So you can use the underscore convention when you don't need to use the value of each iteration. In this way, looking at your code, you'll immediately understand that that loop is only used to carry out a specific task a certain number of times. And not only. Let's try another example. Let's create a list of lists. L equal square brackets 1, 2, 3, square brackets 4, 5, 6, close the square bracket, square brackets 7, 8, 9. Let's say we want to print just the first and the last number of our list of lists. For x, underscore, z. In L, column, new line, print, parenthesis, x, z, and run it. As you can see, we printed just the first and the last number of any lists in our list, using the underscore convention. Now let's discover another way to use the for loop. For index in range parenthesis 0, 10, 2. Column, new line, print, parenthesis, index, and run it. So in the range function, the first number is the starting point. The second number is the arriving point, and the third number are the steps. In this case, we are stepping by 2 and starting from 0, which is why we get printed from 0 to 8, because the arriving number is not used. Now let's create another example. Names equal square brackets, quotation mark, Fred, quotation mark, comma, quotation mark, Bob, quotation mark, comma, quotation mark, Carl, quotation mark, new line, age equals square brackets 28, comma, 19, comma, 22. New line, for name, comma, age in zip parenthesis names, comma, ages. Column, new line, print parenthesis f quotation mark curly brackets name is curly brackets age years old, and let's run it. So using the zip function, we have been able to access any element of 2 different lists in a clean way. And there is more, because if one of the lists is shorter than the other one, it will stop at that point. Let's try. Let's remove the last stage and run it. And just the first 2 names and ages have been printed. Now let's try one last thing, a dictionary comprehension. D equals curly brackets n column n double asterisk 2 4 n in range parenthesis 3. New line, print, parenthesis, type, parenthesis, d, comma, d, and run it. And as you can see, we created our first dictionary using dict comprehension. Now let's recap. Lesson 25 hyphen more for loop uses. We learned about the underscore convention, for underscore. We learned about a new way to use the range function. We learned about the zip function. And we learned about the dict comprehension. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about chained comparison, which is the ability to combine multiple comparison operations into a single expression. Let's create the file. Lesson 26 hyphen chained comparison .py. Let's make a multiple assignment n1, comma, n2, comma, and 3 equals 1, comma, 2, comma, 3. New line, if n1 less than n2 less than n3, column, new line, print, parentheses, quotation marks, n1 less than n2 less than n3, and run it. And as you can see, the chained comparison returned true, which led to printing. Now let's create a list. L1 equals square brackets 1, 2, 3. New line. L2 equal L1. New line. L3 equal L1 dot copy. Parentheses. Let's print them. New line. Print parentheses L1, L2, L3. And as you can see, they look the same, but are they really the same thing? Let's discover it. New line, print, parentheses, F, quotation marks, L1, column, curly brackets, ID, parentheses, L1, close the parentheses, backslash, N, L2, column, curly brackets, ID, parentheses, L2, close the parentheses, backslash, N, L3, column, curly brackets, ID, parentheses, L3, and run it. And as you can see, L1 and L2 has the same identifier. L3 has a different one. What does it mean? Let's try something else. If L1 double equals L2 double equals L3, column, new line, print, parentheses, quotation mark, L1 equal L2 equal L3. As you can see, they are the same thing. Now, let's try something else. If L1 is L2 is L3, column, new line, print, parentheses, quotation marks, L1, L2 and L3 have the same ID. New line, else, column, print, parentheses, L1, L2 or L3 have different IDs. And as you can see, using the chained comparison and the is operator, we compared the ID of our list. Now, let's try to add an elif. Elif L1 is L2 is not L3, column, new line, print, parentheses, quotation mark, L1 and L2 have the same ID, comma, L3 has a different ID, and run it. And there it is. Now let's try to change a value in a list. L2 square brackets 0 equals 10. New line, print, parentheses, L1, L2, L3. and run it. And as you can see, the lists with the same identifier have changed. The other one has not, which is why it's very important to use the copy method. Now let's recap. Lesson 26 hyphen chained comparison. We learned about the chained comparison. We learned about the ID function. And we learned how to use the is and not operators. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to learn how to read the documentation of Python using the dir and help function. Let's create the file lesson 27 hyphen documentation.py. First, let's try to use the dir function. Print parenthesis dir parenthesis and run it. When the dir function has called without arguments, returns a list of names in the current local scope, which is why all the import we made will be listed. Now let's try to use it with an argument. Print parenthesis dir parenthesis double underscore built-ins double underscore and run it. And as you can see, we printed all the built-in functions of Python, which are functions that are always available. You may recognize some of them, like zip, range, type, tuple, str, print, Frozenset. Then there are all the available exceptions, and the Boolean true and false, plus some special attributes. Now, let's try to use the dir function with a function we already used. But first, let's create a divider, print, parentheses, quotation marks, hash, asterisk, 50. New line, print, parentheses, dir, parentheses, print. As you can see, we printed a list with a lot of attributes. Those are Dunder methods. Dunder stands for double underscore. And if you are looking for the documentation, the Dunder doc is what you are looking for. Let's try it. Print parentheses print dot double underscore doc double underscore and run it. As you can see, we printed the documentation of the print function, which tells us where it prints to a stream or to a sys.stdout, and which arguments we can use to modify, for example, what is the last value. We can use also a function to explore the documentation. Let's try. Help, parentheses, print, and run it. And as you can see, we obtain almost the same as before, maybe more clear and detailed. For example, we can see the default values, the space as separator, the new line character as end value, and so on. Now let's click enter to terminate. Now let's copy the line with the divider, Ctrl C, Ctrl V. Comment the help line, print parentheses list dot append dot double underscore doc double underscore and run it. As you can see, append object to the end of the list. Let's try to use the help function. Help parenthesis list dot append. And as you can see, a bit more as before, it's more clear the output of the help function, but it's almost the same. Now let's import a couple of modules. Import math, comma, sys. Let's create another line, paste, print, parenthesis, dir, parenthesis, math, and run. And as you can see, here there are all the functions inside the math module. Log, log10, sin, sqrt, and so on. Now let's read the documentation of one of that. Print, parenthesis, math dot log. That double underscore doc double underscore and run it. Return the logarithm of x to the given base. Perfect. Let's paste another divider. Then print parenthesis sys dot std lib underscore module underscore names and run it. This print contains all the modules that you can use from the Python standard library. For example, Oz, math, and so on. Now let's try to filter the elements that start with an underscore. But first, let's read the documentation about the filter function. Print, parenthesis, filter, dot, double underscore, doc, double underscore, and run it. So it wants a function or none and an iterable, which will be our Frozenset. And the function will be a Lambda function and returns a filter object that we will transform into a set. So the final set function that we want to generate will be composed of all the elements of the Frozenset that returns true in the Lambda function. Let's do it. Filter, parenthesis, comma, and before, close the parenthesis after the iterable, lambda, x, column, not x dot star suite, parenthesis, quotation mark, underscore. This way should filter all the elements that starts with an underscore. Let's make a set of this and then let's put everything in the sorted function. Let's try. And here it is. There are the time module, there are the sys module, the math module, showTil, random. Those are all available modules of the Python standard library. Now let's try another interesting thing. Let's try to run Python from the terminal. Python, if you have Linux, is probably Python 3. dir, parentheses, print, and push enter. In the terminal, we can run any function we will write into a file. If the function returns a value, it will be automatically printed. So the terminal is perfect to use the dir and the help function. Let's try to use the help function, help, parentheses, print. And we obtain the same as before. Then exit, parentheses, enter, and you are back in your terminal. Now let's recap. Lesson 27 hyphen documentation. We learned about the dir function. We learned about the help function. We learned about the filter function and the sorted function. And we learned about the double underscore doc, double underscore. And we learn about the std lib underscore module underscore names, which contains all the function available in the standard library. And we learn how to use some command from the terminal. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about the main block, which will serve as the entry point of our programs from now on. Let's create the file, lesson 28 hyphen main block.py. Let's create a function, def main, parentheses, column, new line, print, parentheses, double underscore, file, double underscore. We already saw this special variable in the last lesson, but we didn't use it. So, this special variable holds the path of the current Python file, and it will be useful to illustrate a point in this lesson. Now, let's create the true main block. If double underscore name double underscore double equals quotation mark double underscore main double underscore close the quotation mark column new line main parentheses and run it. And as you can see, we obtain the path of the file in which it is. But how it's possible? It's possible just if the double underscore name double underscore it's equal to double underscore main double underscore. That's the only way to allow the execution of the main function. So let's try to print the double underscore name double underscore variable. Print parentheses f quotation mark double underscore name double underscore equal curly brackets double underscore name double underscore and run it. And as you can see, it's equals to double underscore main double underscore. That's because when a Python file is executed, the double underscore name double underscore is set to double underscore main double underscore. In this way, what's inside the main block will be executed. Now, Programs are usually composed of many files. So what's happened in the other files to the _name variable? Let's discover it, creating a new file using a function. So def create _ test _ file parenthesis column new line with open parenthesis quotation mark test _ file dot py quotation mark comma quotation mark w quotation mark close the parenthesis as file column new line file that write parenthesis, and let's copy the main function and the main block inside here. 6 quotation marks, new line, and let's copy everything down here. Def main, if name, and paste it. Now let's call this function create _ test _ file and run it. And as you can see, we created our test _ file.py, which is equal except for the create test function. Now let's try to run it, and as you can see, also here the _name is equal to _main . when we run it from that file. Now let's try to import that file into our main file. Import test _ file test _ file dot main. As you can see, our _name it's equal to main. Instead, the _name of the imported file it's equal to test _ file. So only the executed file has the variable name set to main. The all other imported file, not directly executed, has the name of the file itself. Now let's delete the test file and the PyCache folder up here, and let's recap. Lesson 28 main block. We learned about the main block. We learned about the _name . We learned about the file . And for this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to talk about annotations, which are used to improve code clarity and create documentation. Let's create the file lesson 29 annotation.py. Let's create a function def breathe parenthesis name. Till here, nothing new. Now, column str, close the parenthesis, arrow symbol str, column new line return f string hello curly brackets name. new line, def main, parenthesis, column, new line, print, parenthesis, greet, parenthesis, quotation marks, red. And now let's create the main block. If double underscore name double underscore double equals quotation marks double underscore main double underscore new line main parenthesis and run it. As you can see, this is a very simple function, but will be easier to understand what a function does by just reading the annotations. And there is more, because we can access any annotations by using the special variable double underscore annotations double underscore. Let's try to print that annotations. Print parenthesis greet dot double underscore annotations double underscore and run it. And as you can see, we printed our annotation, which contains the name of the variable and his expected types, in this case a string, and what will be the returned expected type, in this case a string. Now let's create a docstring annotation. Triple quotation mark, greet a person, triple quotation marks. And let's print also this docstring annotation. Print parenthesis greet dot double underscore doc double underscore and run it. As you can see, we printed also the docstring annotation. That's a really good practice to keep documentation of your code. Now let's create another function. Def triangle underscore area parenthesis base column float comma height column float arrow symbol float column new line area column float equal base multiplied by height divided by 2. New line, return, area. Let's print it. Print, parenthesis, triangle area, parenthesis, 5.5, comma, 2.3. And let's print also the annotations. Print, parenthesis, triangle underscore area dot double underscore annotations double underscore and run it. And as you can see, we printed the annotation and we printed the result of the calculation. Now, what happens if we insert a different type from the one we specified in the annotation? Let's try. Print, parenthesis, triangle underscore area, parenthesis, 4, 8, and run it. And as you can see, it works anyway. That's because annotations improve readability and are useful to manage documentation, nothing else. Now let's try to print the largest area calculated using our function. Let's create a global variable. Largest underscore area equal 0. This variable is a global variable because it's accessible from anywhere in your code. Let's try to access it by printing it. Print, parenthesis, largest underscore area, and run it. And as you can see, it printed 0. Now, let's modify our function so that every time we call it, the largest value saved is compared to the newly calculated area, and if it's larger, we reassign the new area to the global variable largest area. So if area bigger than largest underscore area, column, new line, largest underscore area equals area. Now there is an issue. When you want to access a global variable, it's not a big deal. But when you need to reassign it, you need to use the global keyword. Otherwise, the compiler will return an error or create a local variable with the same name as the global variable. So let's add in the first line of our function the global keyword followed by the variable name. So global largest underscore area, and let's run it. And as you can see, we obtain that the largest area is 16. Now let's recap. Lesson 29 hyphen annotation. In this lesson we learned about annotations. We learned about the double underscore annotations, double underscore. We learned about the double underscore doc, double underscore. And we learned how to deal with a global variable. For this lesson it's enough. Thanks for watching and see you in the next lesson. In this lesson we are going to create Tetris, the game. Let's get started. First, let's create the file lesson 30 hyphen Tetris.py. Then let's import some functions from os import system, from time import sleep, from random import choice, from msv crt import kbhit getch. And now let's create some constants. Board underscore width equals 10. Board underscore height equal 10. Drop underscore rate equals 3. And then let's create all the shapes of a common Tetris game. Shapes equals square brackets, square brackets, square brackets, 1, 1, 1. Close the square brackets, comma, new line, square brackets, 0, 1, 0. As you can see, you can recognize which piece is this one. Now I'm going to copy the other one. And as you can see, all the pieces are symbolized by the numbers, which are different because any numbers will be a different color. Let's create also the colors. Colors equal square brackets, quotation marks, backslash 033, square brackets, 38, semicolon, 5, semicolon, 8, m, and remove the square bracket, comma, and then I'm going to pass again the other colors. Any of these strings represent a different color. Now let's create some global variable. Playing equal true. Let's create the board. Board equal square brackets, 0, for underscore in range parenthesis board underscore width, for underscore in range parenthesis board underscore height. So the board starts as a list of zeros. Then let's pick the block randomly. Block equal choice parenthesis shapes, new line, block underscore x equal board underscore width double slash 2 minus 2. So the block will start from the middle. Let's take care also of the vertical side. Block underscore y equals 0. And let's set also the scores. Score equal 0. Lines equal 0. Now let's create the main. Def main parenthesis column new line while playing, column new line print underscore board parenthesis new line sleep parenthesis 1/drop underscore rate, and then let's create the main block. If name double equals quotation marks double underscore main double underscore column new line main parenthesis. And now let's create this function def print underscore board parenthesis new line. First we need to know the color of the current block, so block underscore color equal square brackets C for C in block square brackets 0 if C not equal to 0. And then we are going to take the first element of this list, so square brackets 0. Then new line system parenthesis quotation marks CLS. And then we can start the loop through the board for y in range parenthesis board underscore 8 column new line for x in range parenthesis board underscore width column new line if x in range parenthesis block underscore x comma block underscore x plus len parenthesis block square brackets 0 and y in range parenthesis block underscore y comma block underscore y plus len parenthesis block column new line if block square brackets y minus block underscore y close the brackets square brackets x minus block underscore x not equal to 0 column new line print parenthesis colors square brackets block underscore color plus quotation mark. And now you can copy the square from the description of the video down here and paste. Plus colors square brackets 0, comma, and equal quotation marks space. And then let's copy this line, new line, else, column, and paste. Let's change the square into a dot, and let's change block underscore color to board square brackets y square brackets x. New line, the indent, else, column, if board square brackets y square brackets x not equal to 0, column, new line, let's paste again, let's change the board underscore color to board of y and x, new line, else, column, new line, let's paste again, and let's change again into a dot into board of y and x. New line, the indent twice, call an empty print, new line, the indent, print, parenthesis, quotation mark, hyphen, quotation mark, multiplied by, parenthesis, board underscore width, multiplied by 2, minus 1. And then let's print also the scores. Print, parenthesis, f-string, lines, column, curly brackets, lines, score, column, curly brackets, score, and run. As you can see, here is the board, where is the block, and we have to make this block move downwards. So let's create this function, move underscore down, parenthesis. Let's create this function, def move underscore down, parenthesis, column, new line. We need to access block underscore y, so global block underscore y, new line, and then we have to check for collision. So we are going to create a new function, if detect underscore collision, parenthesis, block underscore x, comma, block underscore y plus 1, comma, block. Close the parenthesis, column, new line. In that case, we are going to place the block. So let's create another function, place underscore block, parenthesis, new line, else, column, block underscore y plus equal 1. Let's create those functions, def detect underscore collision, parenthesis, x, comma, y, comma, block, column, new line, for row in range, parenthesis, len, parenthesis, block, column, new line, for call in range, parenthesis, len, parenthesis, block, square brackets, 0, column, new line, if block, square brackets, row, square brackets, call, not equal to 0, column, new line, if x plus col less than 0, or x plus col bigger or equals to board underscore width, or y plus row bigger or equal than board underscore height. Column new line, return true. New line, board square brackets y plus row square brackets x plus col different than 0, column new line, return true. New line, otherwise return false. Now let's create the other function, def place underscore block parenthesis column new line global block underscore x comma block underscore y comma block. Block underscore color equals square brackets C for C in block square brackets 0 if C not equals to 0. First element, so square brackets 0. New line for row in range parenthesis len parenthesis block. Column new line for col in range parenthesis len parenthesis block square brackets 0. Column new line if block square brackets row square brackets col not equals to 0, column new line board square brackets block underscore y plus row square brackets block underscore x plus col equals to block underscore color. In this way, we are converting the zeros on the board into numbers that represent the color and the shape of the block. Once we place the block, we have to create another one. So let's do it. Block equals choice parenthesis shapes block underscore x equal board underscore width divided by 2 minus 2 block underscore y equals to 0, and then let's check if there is already a collision, which will end the game. If detect underscore collision parenthesis block underscore x comma block underscore y comma block column new line game underscore over parenthesis, and let's create this function def game underscore over parenthesis column new line global playing equals false, and let's run it. As you can see, the pieces are falling, and then the game ends by itself. Perfect. So now we have to create the interaction. So let's create a function, get underscore input, parenthesis, and let's create this function, def get underscore input, parenthesis, column, new line, key equals get underscore pressed underscore key, parenthesis, and let's create this function, def get underscore pressed underscore key, parenthesis, column, new line, key equal empty string, new line, while kb hit, parenthesis, column, new line, key equals to get ch, parenthesis, dot decode, parenthesis, square brackets, 0, new line, return key. So let's manage the keys, match key, column, new line, case, quotation marks, q, column, new line, game underscore over, parenthesis, new line, case, quotation marks, a, column, new line, move underscore left, parenthesis, new line, case, quotation marks, d, column, move underscore right, parenthesis, new line, case, quotation marks, s, column, move underscore down, parenthesis, new line, case, quotation marks, w, column, new line, rotate underscore block, parenthesis, new line, and let's create these functions, def move underscore left, parenthesis, column, new line, global, block underscore x, new line, if not detect underscore collision of parenthesis, block underscore x minus 1, comma, block underscore y, comma, block, column, new line, block underscore x minus equal 1. That's very similar to the move underscore right, so let's copy all the inside of this function, and then def move underscore right, parenthesis, column, and let's paste here, and instead of minus and minus it becomes plus and plus. Now we have to create the rotate function, def rotate underscore block, parenthesis, column, new line, global, block, new line, rotated underscore block equals to square brackets, block, square brackets, j, square brackets, I, for j in range, parenthesis, len, parenthesis, block, and for I in range, parenthesis, len, parenthesis, block, square brackets, 0, minus 1, comma, minus 1, comma, minus 1. In this way, we are starting from the last element and going backward. New line, if not detect collision, parenthesis, block underscore x, comma, block underscore y, comma, rotated underscore block. column, new line, block equals rotated underscore block. So in this way we should be able to move and rotate our blocks. Let's try. As you can see, it works. Can rotate the blocks. Okay. Now we need to clear the row when they are full. So let's create a function, clear underscore rows, parentheses, and let's create the function. Def clear underscore rows, parentheses, column, new line, global, board, comma, score, comma, lines. New underscore board equals square brackets, 0, 4, underscore in range, parentheses, board underscore width, 4 underscore in range, parentheses, board underscore height. New line, row index equals board underscore height -1. New line, count equals 0. Let's create a lambda function, is underscore full equals lambda row column all parentheses board square brackets row. New line, 4 row in range parentheses board underscore height upward, so -1 comma -1 comma -1 column, new line, if is underscore full parentheses row, column, new line, lines plus equals 1, count plus equal 1, and continue. New underscore board, square brackets, row, index, equals, board, square brackets, row, row, underscore index, minus equal, 1. And then let's manage the score, score plus equal, square brackets, 0, 40, 100, 300, 1200. Square brackets, count. In this way we can assign different points if the lines are made all together. Then board equal new underscore board. So that's everything. Let's try it. So let's try to clear some rows. Okay. Now let's try. Okay, it works. Let's keep going. Okay. Oh, again, 2 lines. The lines is correct, the score is correct. 3, 120. I would like to try 2 lines, but no. I think, okay. So let's recap. Lesson 30 - Tetris. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to install a few things that we'll use in our intermediate Python course. I assume you have already installed and configured Python and VS Code. If you haven't, I'll include the link in the description so you can get ready for this course. But if it's your first experience with Python, I strongly suggest you to follow the entire beginner tutorial. I'll also include the link in the description. So, let's open a browser and let's search for Git. Click on Git, download for Windows, and click here to download. Now click the exe file. Yes. Next. Next. Yes. Next. Next. Change this in Use Visual Studio Code. Next. 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 And install. Anyway, Git is a very useful open source program for managing changes in your code. And now we are going to create a GitHub account, which is useful for hosting your code online, collaborating with others, and sharing your projects. Uncheck and finish. Open a new tab on your browser and search for GitHub. Click on the first link. Sign up. And start your registration. Now enter your email, password, and choose a username. Then complete your registration. Remember to select the free account. And once you are done, you should have an account like this. This is mine. And now let's open VS Code. And let's install some extensions. Of course, Python has to be installed. Then search for Jupyter and click on Install. Then search for SQLite and pick SQLite Viewer. And then Rainbow CSV and install. Now you are ready to start this intermediate tutorial. I suggest you to watch the beginner tutorial as well to fully understand this one. So for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in these intermediate tutorials we'll be writing more advanced code and our programs will often consist of multiple files. That's why it's important to create a separate folder for each lesson. In this lesson, we'll learn how to create nested functions. As you can see, I've already set up the main.py file and the main block. So let's get started. We are going to create a program that allows the user to input 3 numbers separated by spaces. The program will then check if the input consists of exactly 3 valid numbers and print them. So let's create a variable numbers underscore input equals input parentheses quotation mark write 3 numbers separated by a space parentheses example column 1 0.5 3.14 close the parentheses column space quotation mark parentheses new line valid underscore triplet equals extract underscore valid underscore triplet parentheses numbers underscore input new line print parentheses valid triplet. Now let's create the function def extract underscore valid underscore triplet parentheses numbers underscore str column new line numbers underscore list equal numbers underscore str dot split parentheses quotation mark space quotation mark close the parentheses new line valid underscore numbers equal square brackets and then return square brackets. And finally, let's create our first nested function, which will check if the numbers underscore list contains exactly 3 elements. So def is underscore triplet parentheses n column new line return len parentheses n double equals 3. And now let's create another nested function that will check if the elements are actually numbers. So def is underscore float parentheses n column new line try column new line return float parentheses n new line except value error column new line return none. And then let's create an if statement. If is triplet parentheses numbers underscore list column new line, and let's create a new function process underscore numbers. Let's create it. Def process underscore numbers parentheses column new line for num underscore str in numbers underscore list column new line num equals is underscore float parentheses num underscores str if none is not none, column, new line, valid underscore numbers, that append, parentheses, none. So, if is underscore triplet, parentheses, valid underscore numbers, return valid underscore numbers. And now, usually we would have pushed the button in the top right, but now we want to make something different, so let's create a launch JSON file. Click on Extensions, click on Create Launch JSON File, and click on Python Debugger, Python File. And as you can see, in our folder directory, we created a .vscode folder with inside a launch.json file. This kind of file allows us to debug the current file without any further steps by simply pressing F5. So let's push F5. As you can see, it works. And now let's write three numbers: 1, 2.2, 3.456. As you can see, we obtain the three numbers. Let's try to print something else. 1, A, hash. As you can see, we obtain the empty list. Now let's recap. Lesson 01 hyphen nested function. We learn about nested function. We learn about the F5 button. And we learn how to create the .vscode folder, which the launch JSON inside. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we'll talk about decorators, which are functions that take another function as input, allowing us to modify its behavior. Let's get started. First, let's call a function named square underscore list underscore creator, parentheses. Then let's define it. Def square underscore list underscore creator, parentheses, column, new line. And then let's return a list comprehension. Return square brackets x double asterisk 2 for x in range parentheses 100,000. Now we want to measure the duration of this function. How can we do that? We can use a function decorator. So now let's import time, and then let's define the function decorator. Def time underscore it, parentheses, and here we are going to pass a function. So func, column, new line, inside create a nested function, def func underscore with underscore timing, parentheses, column, new line, set the start start underscore time equal time dot time parenthesis new line print parenthesis start underscore time new line, call the function result equal func parenthesis new line, set then time and underscore time equal time dot time parenthesis new line print parenthesis and underscore time new line, calculate the duration equal and underscore time minus start underscore time new line. Let's print something explanatory. Print parenthesis f double quotation marks function quotation mark curly brackets func that double underscore name double underscore close the bracket quotation mark executed in curly brackets duration column dot 8f close the curly brackets seconds, and then we have to return the result. And then we have to return the returned result calling the function. So return func underscore with underscore timing. The way to decorate a function is to write the decorator on the line before the function declaration, prefixed with that symbol. So at time underscore it. And let's run it. And as you can see, we obtain the time of the execution of this function. So every time we call a function that has been decorated, it's like we are calling the decorator's returned function, which may internally call the original function or perform additional behavior. Now, what if we want to pass an argument to the function? Let's try it. Let's copy this call, change the name, and pass an argument to it. Let's say 200,000. Let's copy the function and paste, change the name, and n. We need to modify the nested function to accept the arguments as well. So let's add asterisk args. In this way we can pass as many arguments as we want. Also here, asterisk args. And now let's run it. It works again. We already saw the asterisk args in the beginning tutorial, and it's a typical way to pass an unknown number of arguments. But what if we want to pass k-value arguments? Let's try to do it. Let's copy this line, change the name, change the argument, and now add two k-value arguments. Comma, threshold equal 100, comma, offset equal 10. Let's copy the function, change the name, none, comma, double asterisk options. In this way we can access the k values we pass from the resulted options dictionary. Let's modify the list comprehension. if options square brackets quotation mark threshold bigger than x and x module options square brackets quotation mark offset double equal 0. We have also to pass the argument to the nested function, so comma double asterisk quarks comma double asterisk quarks and run it. And as you can see, we created a generalized decorator able to take no arguments, one or more arguments, and a dictionary with an unlimited number of k-value arguments. Now let's recap. Lesson 02 hyphen decorator. We learn about decorator. We learn about the @ symbol to call a decorator. And we learn how to use the double asterisk and the common notation quarks and args. So for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about mutable and immutable types. Mutable types, like dictionaries and lists, are objects whose values can be changed after creation. This means you can create them and modify them later. Immutable objects, on the other hand, are objects whose state cannot be changed after creation. An operation that seems to modify an immutable object actually creates a new object instead. Immutable objects include the int, float, string, tuple, and Frozenset. So, let's try to understand this concept better. LST equal mutability. Parentheses. Let's create the function. Mutable equals square brackets 1, 2, 3. New line, print, parentheses, f string, initial list, column, curly brackets, mutable. Now let's take also the ID, comma, ID, column, curly brackets, ID, parentheses, mutable. New line, let's create a nested function, def, modify list, parentheses, L, column, new line, print, parentheses, f string, inside function, parentheses, before modification, column, curly brackets, L, comma, \t, ID, column, curly brackets, ID, parentheses, L. Let's copy this line and let's change before into after. In between, L dot append parentheses 4. And we are not returning anything. Modify underscore list, parentheses, mutable. Print, parentheses, f string, final list, column,
curly brackets, mutable, comma, ID, column, curly brackets, ID, parentheses, mutable. New line, return, mutable. And let's run it. As you can see, the ID of our mutable list has always been the same. It never changed throughout the function. Even after we modified it inside the function, the ID remained the same. This demonstrates that mutable objects retain their ID even when their content changes. Now, let's analyze immutability. S equal immutability, parentheses, immutable equal, quotation mark, hello. New line, print, f-string, initial, string, column, curly brackets, immutable, comma, ID, column, curly brackets, ID, parentheses, immutable. Let's create the nested function, def modify underscore string, parentheses, s, column, new line, print, parentheses, f-string, inside function, parentheses, before modification, column, curly brackets, s, comma, backslash t, id, column, curly brackets, id, parentheses, s. Let's copy this line and let's change before to after. Between these two prints, s plus equal, quotation mark, word. This is like an append for a string. And then, in this case, we have to return s. New line, let's call this function modify underscore string, parentheses, immutable. New line, print, parentheses, f-string, final, string, parentheses, unchanged, column, curly brackets, immutable, comma, id, column, curly brackets, id, parentheses, immutable. And let's run it. As you can see, as soon as we modify the string, its ID changes too. Additionally, if we check the original string after the function call, it remains unchanged. This is a clear example of how we need to manage mutable and immutable objects differently. So, to keep the modification applied to an immutable object, you need to return the modified value and assign it to the original variable. Let's do it. Immutable equal modify underscore string, parentheses, immutable. Let's copy the print, paste. Now let's modify unchanged into changed. Line, return, immutable. And let's run it. As you can see, this approach preserves the modification of the string while creating a new separate object with a distinct ID. Mutability and immutability are topics strictly related to hashability. Some objects are hashable while others are not. Mutable objects are usually not hashable, whereas immutable objects are hashable. A hashable object can be used as a key in a dictionary or as an element in a set. How we can check if an object is hashable? Using the hash function. Let's do it. Def hashability parenthesis lst comma s column new line print parenthesis hash parenthesis s new line. Let's try to hash also the list. Try column new line print parenthesis hash parenthesis lst new line except type error as e column new line print parenthesis e. And let's call this function hashability parenthesis lst comma s. And let's run it. And as you can see, the string has been hashed. The list, which is mutable, returned a type error. So let's recap. Lesson 03 hyphen mutable and immutable. We learn about mutable and immutable objects. We discussed hashable and unhashable objects. And we learned a bit more about the ID and hash functions. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about generators. A generator is a function that helps save memory by generating one value at a time, rather than creating and sorting the entire dataset in memory at once. So, let's get started. First, let's create a normal Fibonacci sequence. Sequence equal square brackets a, comma, b equal 0, 1. New line 4 underscore in range parenthesis n column new line sequence dot append parenthesis a new line a comma b equals b comma a plus b. New line return sequence. And now let's call this function for n in Fibonacci sequence parenthesis 5 column new line print parenthesis n. And let's check if it works. Those look like the first 5 numbers of a Fibonacci sequence. Now let's create a Fibonacci generator. A, B equal 0, 1. New line. For underscore in range parenthesis n. Column, new line. And now we are going to use a new keyword that allows the function to return a single value, pausing the loop at that point. Yield A. New line. A, B equals B, A plus B. Let's check if it works. For n in Fibonacci generator, parenthesis, 5, column, new line, print, parenthesis, n, and run it. This also worked, so why could be better to use a generator instead of a normal function? That's because the generator is a memory saver. So let's print the size of these two functions. Print, parenthesis, sys dot get size of, parenthesis, Fibonacci sequence, parenthesis, 100. And also for the generator. New line, print, parenthesis, sys dot get size of, parenthesis, Fibonacci generator, parenthesis, 100. And let's run it. As you can see, the size of the normal Fibonacci sequence is way bigger than the size of the Fibonacci generator. So let's try to make it bigger. Let's copy this line, 1000, and let's copy this line, 1002, and run it. As you can see, the size of the generator is not correlated with the size of the n value, which is why the bigger the n value, the better it is to use the generator. Let's try to use a bigger number, and it's still the same. So if you need an element just one time, the generator is the right solution. Now, let's recap. Lesson 04 hyphen generator. We learn about a generator, and we learn about the yield keyword. For this lesson it's enough. Thanks for watching, and see you in the next lesson. Hi guys, in this lesson we are going to talk about the scope of a variable, which is the region of the program where a variable is recognized and can be accessed or modified. Let's get started. S equal quotation mark initial variable, new line, print, parenthesis, quotation mark, backslash n, local scope. New line, let's call the function assign underscore local, parenthesis, here, print, parenthesis, f string, before function, column, curly brackets, s. New line, print, parenthesis, f string, after function, column, curly brackets, s. Then let's define the function. Let's create a variable s equal quotation mark local variable. New line, print, parenthesis, f-string, inside function, parenthesis, after assignment, column, curly brackets, s. And let's run it. As you can see, we printed two local variables from two different scopes. The first contains the term initial variable, and the second contains the text local variable, and then again the first one. Now, let's copy this and modify local into non-local. Here and also here. Let's define the function. In this case, before assigning a value to our local variable, we are going to use the non-local keyword to indicate that we want to modify the s variable in the upper function. Non-local s. New line, print, parenthesis, f-string, inside function, parenthesis, before assignment, column, curly brackets, s. Let's copy this. New line, s equal, quotation mark, non-local variable. New line, paste, and modify before into after. And let's run it again. As you can see, in this case, the assignment we made in the nested function interferes with the variable in the upper scope. That's because we used the non-local keyword before the assignment. Now let's do the same thing in the assign global function. Let's copy this and paste it. Let's change non-local into global here and here. Now let's call this function. Let's copy this and paste it again. And let's change again non-local into global. And let's run it again. As you can see, in this case, the variable s has not changed. Instead, the s in the global scope now has its value set to global variable. Now let's recap. Lesson 05 hyphen scope. We learn about 3 types of scopes, and we learn how to use the non-local and global keywords. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to create a program to generate passwords randomly. To do this, we will use the config.ini file to pre-configure some variables for our program. So let's get started. First of all, let's create the file config.ini and write the following in it. Square brackets, length, new line, password underscore length equal 16. New line, square brackets, chart types, new line, uppercase, equal true. New line, digits equal true. New line, special equal true. This configuration of the config.ini file allows us to easily read it and get the necessary variables. Now, let's create a global variable with the location of the file, config_file, all uppercase, equal, quotation mark, config.ini. Now, let's define the reader, config equal config parser dot config parser, parenthesis, new line, config dot read, parenthesis, config underscore file, all uppercase, new line. Here we are going to create a dict comprehension, settings equal curly brackets, section, column, dict, parenthesis, config dot items, parenthesis, section, close the parenthesis, for section in config dot sections, parenthesis, new line, return settings. Now let's set settings equal to the output of read underscore config. Settings equal read underscore config underscore option, parenthesis. Now we have to pass the values to the password generator. So password equal generate underscore password, parenthesis, new line, settings, square brackets, quotation marks, length, square bracket again, quotation mark, password underscore length, new line, settings, square brackets, quotation mark, chart types, square brackets, quotation mark, uppercase. Let's copy this line twice and let's change this to special and this to digits. A new line, print, parenthesis, f-string, generated password, column, curly brackets, password. Now let's define the function. Length, comma, uppercase, comma, digits, comma, special. New line, character equal string dot ashy underscore lowercase, new line, if uppercase, column, new line, character plus equal string dot ashy underscore uppercase, new line, if digits, column, new line, character plus equal string dot digits, new line, if special, column, new line, character plus equal string dot punctuation, new line, return quotation marks dot join, parenthesis, random dot choice, parenthesis, character. 4 underscore in range, parenthesis, int, parenthesis, length. And let's run it. As you can see, we obtain a random password. There is another way to pass arguments to a program in Python. Let's try it. If len, parenthesis, sys.argv double equals 5, column, new line, password equal generate underscore password, parenthesis, new line, int, parenthesis, sys.argv square brackets 1, comma, new line, bool, parenthesis, sys.argv square brackets 2. Let's copy this line twice. 4, 3, new line, else, column. Let's indent these lines. Let's try to run it normally. As you can see, it works without passing any arguments. Now let's pass 4 arguments. Python ./main.py 100 true true true. Push enter. As you can see, we generated a 100 character long password. Now let's recap. Lesson 06 hyphen arguments and ini. We learn about config parser to read the config.ini files. We learn about the string module. And we learn how to pass arguments from the terminal using sys.argv. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to learn about CSV. A CSV, separated values file, is a simple text file used to store tabular data, where each line represents a row and values are separated by commas. So we are going to create a program which allows us to update a CSV in order to keep track of our progress in this course. So let's get started. First of all, we have to create the initial CSV with open parenthesis CSV underscore file, comma, mod equal, quotation marks, W, comma, new line equal, quotation marks, as file, column, new line, writer equal csv.writer, parenthesis, file, new line, writer dot write row, parenthesis, square brackets, quotation marks, lesson, number, comma, quotation mark, lesson, name, comma, quotation marks, completed, comma, quotation marks, difficulty, comma, quotation marks, notes. This will be the first line of our CSV, so these will be the names of the columns. Now let's call it if not os dot path dot exists, parenthesis, CSV underscore file, column, new line, create underscore initial underscore CSV, parentheses. And let's run it. As you can see, we created our first CSV, which contains the names of our columns separated by commas. Now let's create the way to update this CSV with our data. While true, column, new line, print, parentheses, quotation marks, \n, options, column, new line, print, parentheses, quotation marks, 1 dot, add or update a lesson, new line, print, parentheses, quotation marks, 2 dot, view progress, new line, print, parentheses, quotation marks, 0 dot, exit, new line, choice equal input, parentheses, quotation marks, enter your choice, column, new line, match, choice, column, new line, keys, quotation marks, 1, column, new line, lesson underscore number equal input, parentheses, quotation mark, enter lesson number, column, new line, lesson underscore name equal input, parentheses, enter lesson name, column, new line, completed equal input, parentheses, quotation marks, is the lesson complete, question mark, new line, difficulty equal input, parentheses, quotation marks, enter perceived difficulty, column, new line, notes equal input, parentheses, quotation mark, enter any notes, column, new line. Now let's call the function add or update lesson, parentheses, lesson underscore number, comma, lesson underscore name, comma, completed, comma, difficulty, comma, notes. Let's copy these parameters and paste them here. Let's define this function with open parentheses csv underscore file, comma, mode equal quotation mark r, comma, new line equal quotation marks as file, column, new line, reader equal csv dot reader, parentheses, file, new line, rows equal list, parentheses, reader, new line, for row in rows, column, new line, if row square brackets 0 double equal lesson underscore number, column, new line, we assign the values. Row square brackets 1 equal lesson underscore name. Row square brackets 2 equal completed. Row square brackets 3 equal difficulty. Row square brackets 4 equal notes. Break. So if the loop ends cleanly, it means that we have to append a new row. Else column rows dot append parentheses square brackets, and let's paste them again. New line with open parentheses csv underscore file comma mode equal quotation marks w comma new line equal quotation marks as file column new line writer equal csv dot writer parentheses file new line writer dot write rows parentheses rows new line print parentheses f string updated curly brackets csv underscore file. Now let's run it. One nested function. Yes. 2 nothing to say. Let's open the file, and as you can see we added a new row. Let's try to update this row. One nested function. No. Let's say 3 this time. Watch it again. And as you can see, we update the row. Let's create the other cases. Case quotation marks 2 column new line view progress parentheses new line case quotation marks 0 column new line print parentheses quotation marks exiting program new line break new line case underscore column new line print parentheses quotation marks backslash n invalid choice. Let's define the function print parentheses quotation marks backslash n viewing progress column new line with open parentheses csv underscore file comma mode equal quotation marks r comma new line equal quotation marks as file column new line reader equals csv dot reader parentheses file new line for row in reader column new line print parentheses row. Now let's run it. 2. And as you can see, we printed our progress. Now let's try to push 3. Invalid choice. And now let's try to exit. And it works. Now let's recap. Lesson 07 -CSV. We learned what is a CSV and how to use it. We learned the writer function, the write row function, the write rows function, and the reader function. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to learn about pip, the Python package installer. Pip allows us to install new packages, making it possible to perform more complex and advanced tasks in Python. Pip is a tool that usually comes bundled with Python. We can use pip to get information about the installed packages on our system by running the command pip list. As you can see, I've only one package installed, which happens to be pip itself. Here is the version. Now, let's try to get more info about pip using pip show pip. As you can see, we obtain the name, version, and a summary that tells us pip is the recommended tool for installing Python packages. So let's use it to install a new package. Pip install NumPy. You should see something like this. Now let's check if this new package appears in the list. Pip list. And here it is. Now, the best thing to do after learning how to install something is to learn how to remove it. So, pip uninstall NumPy. Why? Now let's check if NumPy has been removed. Pip list. And as you can see, now we have just pip. So let's reinstall NumPy. Pip install NumPy. Let's check again. Pip list. Now let's talk about NumPy. NumPy is one of the most famous modules in Python, known for its fast execution due to being written in pure C. So let's try to use it. Import NumPy as MP. If you are not getting any error, you are using the correct environment. Otherwise, you need to change in VS Code the environment you are using right now. Then let's import a function from GitHub. Click on the link in the description. Let's copy this function decorator. And let's paste it. In this program, we want to explore NumPy and demonstrate its speed. To do this, we will compare the execution time of a function written in pure Python with one written using NumPy. So let's set the array length, array underscore len, ten double asterisk 6, new line, and 1 equal pure underscore Python parenthesis array len, and 2 equal pure underscore NumPy parenthesis, array underscore len. Let's define the function. A equal list parenthesis range parenthesis size. Let's copy this line. Let's call this B. New line. C equal A square brackets I plus B square brackets I for I in range parenthesis size. New line, return C. Let's add the decorator at time underscore it. Add also here at time underscore it. And then let's do the same in NumPy. A equals mp dot arrange parenthesis size. Let's copy this line. Let's change this to B. And then C equal mp dot add parenthesis A comma B. New line, return C. And let's run it. And as you can see, the pure NumPy function, it's way faster than the pure Python function. So now let's print something. Print parenthesis f string curly brackets type parenthesis n1. Curly brackets type parenthesis n2. Backslash n backslash new line f string curly brackets all parenthesis n1 double equals n2 backslash n backslash new line f string curly brackets n1 square brackets column 10 curly brackets backslash n curly brackets n2 square brackets column 10. So in the first line we are going to see the type of these two arrays. As you can see, they are different. In the second line we compare the two arrays and we make it return true if all the elements are equals. And then we printed the first 10 elements. And as you can see, they are the same. Now let's play a bit with NumPy. Let's make the array more manageable. n2 equal n2 square brackets n2 minor than 50. New line, print n2. In this way we are getting the elements that are less than 50. n2 equal mp dot where parenthesis n2 module 3 double equals 0 comma n2 comma 0. New line, print n2. So if it's not equal to 3, it's going to become 0. As you can see, it works. Now let's reshape n2 equal mp dot reshape parenthesis n2 comma parenthesis 5 comma 5. New line, print n2. As you can see, now we obtain an array of 5 by 5. Let's print the shape, print, parentheses, and 2 dot shape. Print, parentheses, mp dot square, parentheses, and 2. As you can see, it works. Now let's recap. Lesson 08-pip. We learn about pip. We learn about how to see all the package installed. We learn how to use show, and we learn how to use install and uninstall. And then we learn how to use NumPy. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to explore virtual environments, a widely used solution for managing the various programs and dependencies. As you begin using more external packages, you'll eventually encounter compatibility issues when installing new ones. This is where virtual environments come in. They are the perfect solution for managing different package versions and avoiding conflicts. So let's create our first virtual environment. Ensure to use the command prompt instead of the PowerShell. First, let's get some information about our current environment using where Python. These two paths represent the current location of the python.exe file, which is responsible for executing our Python scripts. And that is just a part of our current environment. Now let's get the list of the packages installed in our current environment using pip list. In short, the path to the python.exe file and the list of installed packages together define an environment. Now, let's create our virtual environment. Python -m venv dot venv and push enter. Click on yes, and up here you should see a new folder named .venv, which is full of folders, but we'll discuss this in more detail shortly. First, let's activate the environment. /venv /scripts /activate. As you can see here, the name of the virtual environment appears in parentheses. Now that we activated the environment, the path and the list of the packages should be different. Let's check. Where? Python. As you can see, the path to the python.exe file now points to the one in the folder we just created, which is the folder of our virtual environment. Let's check also the list of packages, pip list. As you can see now, we have just the pip installed. Now that we learned how to activate an environment, it's important to understand how to deactivate it. So, let's modify the command used to the activation into deactivate.bat. And now let's test if the environment has been deactivated. Pip list. As you can see, it is. Now let's reactivate it and let's install two new packages. Pip install numpy matplotlib. Push enter. You should see something like this. And then let's test it. Pip list. Okay, we obtain a lot of packages. Now let's create the Python program. Import numpy as mp. New line. Import matplotlib dot pyplot as plt. This program will display graphs of mathematical functions. So first we need to set up the plot. Fig, x equal plt dot subplots parenthesis new line ax dot set underscore x lim parenthesis -4, 4 new line ax dot set underscore y lim parenthesis -4, 4 new line ax dot set underscore title parenthesis quotation marks function visualizer new line ax dot set underscore x label parenthesis quotation mark x new line ax dot set underscore y label parenthesis quotation marks f parenthesis x new line ax dot grid parenthesis true new line ax dot plot parenthesis 0, 0, quotation marks row new line return fig, ax. Now let's create the function return mp.scene parenthesis x and add x to the parameter. Now let's call it from the main scene underscore func parenthesis. Now let's create the function decorator dev visualize parenthesis. Let's add the func to the parameters. Then x equal mp dot line space parenthesis -4, 4, 1000 new line y equal func parenthesis x new line fig, ax equal setup underscore plot parenthesis new line ax dot plot parenthesis x, y, lw equals 2, color equal quotation marks blue, label equal quotation mark function new line ax dot legend parenthesis new line plt dot show new line return visualize. Now let's decorate the function and let's run it. And as you can see, we obtain a visual representation of the scene function. Now let's create also the cos function. Copy, paste, and cos, and cos again. Let's call this function cos underscore func, parenthesis. Here is the sin, and here is the cos. Now let's recap. Lesson 09 hyphen virtual environment. We learn what is a virtual environment and why it's useful. We learn how to activate it and deactivate it. We learn how to use the where command. And we learn how to use matplotlib to display graphs. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to create a small GUI, graphical user interface, that allows the user to create small pixel art. Let's get started. First, open your terminal and select command prompt. And let's create the virtual environment, python -m venv.venv. Push enter, click on yes. Let's check the current packages. Okay, let's activate the environment /venv /scripts /activate. Click enter. Let's check it. Pip list. Okay, now let's install a new package, pip install pillow. Let's check the installation, pip list. Okay. Let's import other functions. From pil import image, image draw. Let's define some variables. Read underscore size equal 16. Line block underscore size equal 20. Root equal none. Brush color equal quotation mark black. New line is underscore painting equal false. Image equal none. New line draw equal none. Let's call the root application root.main loop. Parenthesis. Root is the main application window and main loop keeps the GUI active. Now, let's set all the information for the window to create a wrap. Global root, image, draw. Root equal tk.tk parenthesis new line root dot title parenthesis quotation marks pixel art editor. and let's run it. Okay, it works. Now let's update the contents of the window. New line, image equal image dot new parentheses quotation marks RGBA comma parentheses grid size multiplied by block size comma grid size multiplied by block size comma parentheses 0 comma 0 comma 0 comma 0 new line draw equal image draw dot draw parentheses image main underscore frame equal tk dot frame parentheses root new line main underscore frame dot pack parentheses fill equal tk dot boot comma expand equal true new line color underscore frame equal tk dot frame parentheses main underscore frame new line color underscore frame dot grid parentheses row equals 0 comma column equals 0 comma pad equal 10 comma pad y equal 10 comma sticky equal quotation marks ns new line color underscore buttons equal square brackets new line colors equal square brackets quotation mark black comma quotation mark white comma quotation mark gray comma quotation mark red comma quotation mark blue comma quotation mark yellow comma quotation mark orange comma quotation mark green new line for color in colors column new line create color button parentheses color let's add some global variables color underscore buttons comma color underscore frame and let's define the function call equal len parentheses color underscore buttons module 10 plus 1 row equal len parentheses color underscore buttons floor divided by 10 line button equal tk dot button parentheses color underscore frame comma bg equal color comma width equal 3 comma height equal 2 comma command equal lambda column change underscore color, parenthesis, color. New line, button dot grid, parenthesis, row equal row, comma, column equal col, comma, pad y equal 2. New line, color underscore buttons dot append, parenthesis, button. Now let's define the change color function. Global, brush underscore color, new line, brush underscore color equal new underscore color. Should be okay, so let's try to run it. As you can see, we generated the buttons to choose the color. Now let's create the canvas where we can draw. Canvas underscore frame equal tk dot frame, parenthesis, main underscore frame. New line, canvas underscore frame dot grid, row equal 1, comma, column equal 0, comma, pad x equal 10, comma, pad y equal 10. New line, canvas equal tk dot canvas, parenthesis, canvas underscore frame. New line, canvas dot pack, parenthesis, new line, canvas dot bind, parenthesis, quotation marks, angle bracket, button, hyphen 1, comma, start underscore paint. New line, canvas dot bind, parenthesis, quotation marks, angle brackets, b1 minus motion, comma, paint. New line, canvas dot bind, parenthesis, quotation marks, angle brackets, button, release, hyphen 1, comma, stop, paint. Let's add the global variables, canvas, and let's define the functions. Global is underscore painting, new line, is underscore painting equal true. New line, paint, parenthesis, event. Let's define the other function. Global is underscore painting, new line, is underscore painting equal false. Now the other function, if not is underscore painting, new line, return. New line, x underscore index equal event.x floor divided by block underscore size, y underscore index equal event.y floor divided by block underscore size. New line, if 0 minor or equals than x underscore index, minor than grid underscore size, and 0 minor or equal than y underscore index, minor than grid underscore size, column, new line, x0 equal x underscore index multiplied by block size, new line, y0 equal y underscore index multiplied by block size, new line, x1 equal x0 plus block underscore size, new line, y1 equal y0 plus block underscore size, new line, draw that rectangle, parenthesis, square brackets, parenthesis, x0, comma, y0, comma, parenthesis, x1, comma, y1, comma, fill equal brush underscore color, new line, canvas dot create underscore rectangle, parenthesis, x0, comma, y0, comma, x1, comma, y1, comma, fill equal brush underscore color, comma, outline equal quotation mark black, comma, width equal 1. Now let's call the redraw underscore canvas function. And let's define it. Canvas dot config parenthesis width equal grid underscore size multiplied by block underscore size, comma, height equal grid underscore size multiplied by block underscore size, line, canvas dot delete parenthesis quotation mark all, new line, for y in range parenthesis grid underscore size column, new line, for x in range parenthesis grid underscore size column, new line, x0 equal x multiplied by block underscore size, new line, y0 equal y multiplied by block underscore size, new line, x1 equal x0 plus block underscore size, new line, y1 equal y0 plus block underscore size, new line, color equal image dot get pixel parenthesis x0 comma y0, new line, hex underscore color equal quotation mark hash curly brackets column 02 x 3 times. dot format parentheses unpack color square brackets column 3. New line canvas dot create underscore rectangle parentheses x0 comma y0 comma x1 comma y1 comma fill equal hex underscore color comma outline equal quotation mark black comma width equal 1. And let's try it. Let's draw something. Very nice. Now we had to create the button to create colors. So costume underscore color underscore button equal tk dot button parentheses color underscore frame comma text equal quotation mark plus comma command equal create costume color. New line costume underscore color underscore button dot grid parentheses row equal 0 comma column equal 0 comma pad x equal 10. Now let's define the function. Global brush underscore color new line color underscore code equal color chooser dot ask color parentheses square brackets 1. New line if color underscore code column brush underscore color equal color underscore code. New line create underscore color underscore button parentheses color code. And let's try it. Let's click the button. Let's say a pink. Click OK. And that's it. Let's try it. It works. Enjoy it. Now we can create a menu to save and load images. Menu underscore bar equal tk dot menu parentheses root new line root dot config parentheses menu equal menu underscore bar new line file underscore menu equal tk dot menu parentheses menu underscore bar comma tear off equal 0 new line, menu underscore bar dot add underscore cascade, parenthesis, label equal, quotation marks, file, comma, menu equal, file underscore menu, new line, file underscore menu dot add command, parenthesis, label equal, quotation marks, new, comma, command equal, new underscore image. Now let's create this function, def new underscore image, parenthesis, column, new line, global, image, comma, draw, new line, image equal, image dot new, parenthesis, quotation mark, RGBA, quotation mark, comma, parenthesis, grid underscore size multiplied by block underscore size, comma, grid underscore size multiplied by block underscore size, comma, parenthesis, 0, 0, 0, 0. New line, draw equal, image draw dot draw, parenthesis, image. New line, redraw underscore canvas. Let's try it. Let's draw something and then new. Let's try again, and it works. Let's add new functions, file underscore menu dot add underscore command, parenthesis, label equal, quotation marks, open, comma, command equal, open underscore image, new line, file underscore menu dot add underscore command, parenthesis, label equal, save, comma, command equal, save underscore image. Let's define the function, def open underscore image, parenthesis, column, new line, file underscore path equal, file dialog dot ask open file name, parenthesis, file types equal, square brackets, parenthesis, PNG files, comma, quotation marks, asterisk dot PNG, comma, new line, parenthesis, quotation marks, all files, comma, quotation marks, asterisk dot asterisk, new line, if file path, column, new line, img equal, image dot open, parenthesis, file underscore path dot convert, parenthesis, quotation mark, RGBA, new line, img underscore resized equal, img dot resize, parenthesis, grid underscore size multiplied by block underscore size, comma, grid underscore size multiplied by block underscore size, comma, image dot nearest. New line, global, image, comma, draw. New line, image equal, img underscore resized, new line, draw equal, image draw dot draw parenthesis image. New line, redraw underscore canvas. Let's define the save function, def save underscore image, parenthesis, column, new line, file underscore path equal, file dialog dot ask save as file name, parenthesis, default extension equal, quotation mark, dot png, comma, file types equal, square brackets, parenthesis, quotation marks, png files, comma, quotation marks, asterisk, dot png, comma, parenthesis, quotation marks, all files, comma, quotation marks, asterisk, dot, asterisk. New line, if file underscore path, column, new line, resized underscore image equal, image dot resize, parenthesis, parenthesis, grid underscore size, comma, grid underscore size, comma, image dot nearest. New line, resized underscore image dot save, parenthesis, file path. Now let's draw an image. Let's add colors. And now let's save it. As image. Save. Let's check it. It's right there. File, new, and let's open. It looks like the same, so it works. Now let's define the exit function. Def exit, parenthesis, column, new line, root dot destroy. File menu dot add underscore separator, parenthesis, file underscore menu dot add underscore command, parenthesis, label equal, quotation mark, exit, comma, command equal, exit. Let's try it. File, exit, and it works. Let's recap. lesson 10 hyphen pixel art editor. I hope you enjoyed this lesson, which is more of a demonstration of what you can do with Python. So for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson I would like to talk about requirements, which is a common term used to refer to all the dependencies needed to make a Python program work. So let's get started. First, let's open the terminal. Let's choose command prompt. Let's create the virtual environment, python -m venv.venv. Click yes. And now let's activate it. /venv /scripts /activate. And as you can see, it's active. So let's install some package. Pip install request beautiful soup 4. Click enter. And after this, let's check the installation. Pip list. Okay, so these are all the packages we need to run our program. But what if we want to give someone else the ability to run this program? If someone attempts to do the installation at the same time as us, it's easy. Pip install request beautiful soup 4. However, in a few months, the version of the package might be different, and so call the function of this package. The correct way to save the dependencies of a Python program is to save them in a txt file. So let's do it. Using the pip freeze right angle bracket requirements.txt. Let's open the file. As you can see, this is how is usually a requirements.txt file. The name of the package and the version. Now, let's try to install this requirements.txt file instead of how we did. So let's deactivate the environment and let's remove the .venv folder. And now let's create a new environment. But first let's check the current environment. Pip list. Let's recreate the environment. And let's activate it. And now pip install -r requirements.txt. Let's check the installation. Pip list. And as you can see, the same package as before has been installed. Now let's create our program. Import requests. New line from bs4 import beautiful soup. Let's define the main. As you may already understand, this program is designed to scrape a given website. URL equal quotation marks new line scraped underscore data equal scrape underscore website parenthesis URL. new line, if script underscore data, column, new line, save underscore to underscore files, parentheses, scripted underscore data. Now let's pick a site, Forbes.com. As you can see, it's full of text and links. Let's try to take as much as we can. Let's copy the URL. Let's paste it. And let's define the scrape underscore website function. Try, column, new line, response, equal, requests dot get, parentheses, URL, new line, response dot raise for status, parentheses, new line, soup equal, beautiful soup, parentheses, response dot text, comma, quotation marks, HTML dot parser, new line, HTML equal soup dot prettify, parentheses, new line, text equal soup dot get text, parentheses, separator equal, quotation marks, backslash n, comma, strip equal, true, new line, links equal, square brackets, a, square brackets, quotation marks, href, for a in soup dot find all, parentheses, quotation marks, a, comma, href equal true, return, curly brackets, quotation marks, HTML, column, HTML, comma, quotation marks, text, column, text, comma, quotation marks, links, column, links, new line, except requests dot exceptions dot request exception as e, column, new line, print f string, error, column, curly brackets, e, new line, return none. Let's save the files. Timestamp equal datetime dot now, parentheses, dot strf time, parentheses, quotation marks, %y, %m, %d, underscore, %h, %m, %s, new line, folder underscore name equal f string scraped data underscore curly brackets timestamp, new line, os dot make dirs parentheses folder underscore name, new line, with open parenthesis host dot path dot join parenthesis folder underscore name comma quotation marks file dot html comma quotation marks w comma encoding quotation marks UTF-8 as file column new line file dot write parenthesis data square brackets quotation marks HTML, and let's copy these two lines, copy and paste it. Let's change the name text.txt and here text. Let's copy also this and paste it, and let's change the name links and here quotation marks \n dot join parenthesis data square brackets quotation marks links, and that's it. Let's try to run it. Let's check in the files. Here is the folder, and as you can see, this is an HTML page. It's a very long HTML page. Here are the links. Okay. And here the text. All the text in the page. Let's try to open the file.html. Reveal in File Explorer. Double click. And as you can see, here is the link of the page. And it looks very similar to the original. So it means we get a lot of. So that's it. Let's recap. Lesson 11 hyphen requirements. We learn how to use the freeze to create the requirements.txt file, and we learn a bit about requests and beautiful soup for. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to start learning about object-oriented programming. To do that, we first need to understand how to create blueprint for making objects. So let's get started. First of all, have we ever used an object? The answer is yes. Let's take a look. Values equal list parenthesis. Values is an object, just like almost everything else in Python. Now let's use some method of this object. New line. Values dot append parenthesis 10. New line. Values dot remove parenthesis 10. New line. Print parenthesis values. New line. Print parenthesis type parenthesis values. Now we want to create something that can be used like values. To do that, we need to use the class keyword, class calculator. Calculator is going to be our blueprint. Now let's give it at least one attribute. Column, new line, def, double underscore, init, double underscore, parenthesis, self, comma, result, equal 0. Column, new line, self, dot, result, equal, result. The init method is called every time we create an object. This is called instantiating or creating an instance of the calculator blueprint. The self parameter is a convention we use in all the methods inside a class. It allows each method to refer to the object itself. Now let's create some methods. Def add, parenthesis, self, comma, value, column, new line, self dot result, plus equal, value, new line, def subtract, parenthesis, self, comma, value, column, new line, self dot result minus equal value, new line, def get underscore result, parenthesis, self, column, new line, return self dot result. This class allows us to use it in the same way we did with the list class up here. So let's do it again. Calc equal calculator, parenthesis, new line. We don't need to pass any parameter because we already set the result to 0 by default. Because remember, every time we instantiate an object, the double underscore init method is called. Calc dot add, parenthesis, 10, new line, calc dot subtract, parenthesis, 4, new line, print, parenthesis, calc dot get underscore result, parenthesis, new line, print, parenthesis, type, parenthesis, calc. As you can see, we created a blueprint to instantiate objects that behave like a simple calculator of type calculator. Now let's recap. So in this lesson we learned how to use classes to create objects with attributes and methods. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about Dunder methods. Dunder stands for double underscore, because these methods start with 2 underscores. They are special methods that help simplify many things when creating classes. So let's get started. Class, book, column, new line, counter, equal, 0. Counter is a class attribute, which means it is shared by all instances of that class. New line, def, double underscore, init, double underscore, parenthesis, self, comma, title, comma, author, comma, year, column, new line, self dot title equal title, self dot author equal author, self dot year equal year, book dot counter plus equal 1. The double underscore init method is called the constructor because it's the method that's implicitly called when you instantiate an object. It assigns the parameters to the object's attributes and can also do more. As you can see, in this case, it also increments the class attribute by 1. So let's create an instance of this object, book1 equal book parentheses, quotation marks 1984, comma, quotation marks, George Orwell, quotation marks, comma, 1949. Now let's implement other Dunder methods, def double underscore str double underscore parentheses self column new line return f string curly brackets self dot title by curly brackets self dot author curly brackets self dot year, and let's print it. Print parentheses book1. And as you can see, this Dunder method helps us print the object easily, just like we do when we print a list. So we don't need to call the double underscore str method directly, because it's implicitly called when you use print on the object. Now let's create another book, book2 equal book parentheses quotation marks under the skin, comma, quotation marks, Michel Faber, quotation marks, comma, 2000. Let's print it to print parentheses same result. Now let's try to print the counter, print parentheses book dot counter, which is the class attributes and is common to all the objects. And as you can see, it returns 2. Now let's implement another Dunder method, def double underscore del double underscore parentheses self column new line book dot counter minus equal 1 new line print parentheses f string book curly brackets self dot title has been deleted. Right? And let's delete a book, del book1. Print parentheses book dot counter and run it. As you can see, now we have just one book. That's because we use the double underscore there method, which is also called the destructor, to delete one of the objects. And as you can see, the other object was also deleted using the same method, because there were no more references to it in the program. Now let's recap. In this lesson we learn about class attribute and instance attribute. We learn what is a constructor, and we learn a bit more about two Dunder methods, double underscore str double underscore and double underscore del double underscore. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about inheritance, which is one of the fundamental concepts in object-oriented programming. So let's get started. Let's create another class that will inherit from the person class. Class student, parenthesis, person, column, new line, def, double underscore, init, and push tab. And as you can see, a lot of the work we would have had to do is already done. Super is a built-in function used to refer to the parent class. In this way, it allows you to call methods and attributes from the parent class. Let's add a new attribute, self.course equal course. Let's add also up here course, then new line, def, double underscore, str, and tab. Also here super does the same thing, so plus fstring \n course column curly brackets self dot course. Now let's create a student equal student parenthesis quotation marks s123 comma quotation mark Alice comma quotation marks computer science, new line, print parenthesis student. As you can see, we were able to create our student class by doing half the work, because the attributes and the methods we needed were already implemented in the parent class person. This is especially useful when you need to create many subclasses. So let's try another one. Class employee parenthesis person column new line def double underscore init and tab. Let's add parameter comma department and the attribute self dot department equal department, new line def double underscore str tab plus fstring \n department column curly brackets self dot department. And now let's create an employee. Employee equal employee parenthesis quotation marks E456 comma quotation marks Bob comma, quotation mark, HR. Print, parenthesis, employee. As you can see, inheritance is a powerful tool when you need to create multiple classes with shared behavior or attributes. So in this lesson we learn about inheritance and how it allows one class to reuse code from another. We also learned about the super built-in function, which allows us to call parent class method. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys! In this lesson we are going to talk about another fundamental principle of object-oriented programming called encapsulation, which allows you to control the visibility of attributes by restricting access to them within a class. There are different levels of access restriction and we'll see all of them in this lesson. Let's get started. First, let's create the attributes self dot account underscore holder equal account underscore holder. New line. This is a public attribute, as you have already seen. Self dot underscore account type equal quotation marks standard. The underscore at the beginning of the attribute name indicates that it's a protected attribute. This means you should access it through a method or from within a subclass. Self dot double underscore balance equal initial underscore balance. New line. Self dot double underscore pin equal none. The double underscore at the beginning of the attribute name indicates that it's a private attribute. This means you should access it only through a method defined in the class. So these are the three types of access restrictions. By using them, you can enforce how your code is used and protect its internal parts. Now let's create also private and protected methods. Def double underscore validate underscore pin parenthesis self comma pin column new line return is instance parenthesis pin comma int and len parenthesis str parenthesis pin double equals. So this method is accessible only from this class. So let's use it to set the pin. If self dot double underscore validate underscore pin parenthesis new pin column new line self dot double underscore pin equals new pin. We can also create protected methods, so let's do it. Def underscore verify underscore pin parenthesis self comma pin column new line return self dot double underscore pin is not none and self dot double underscore pin double equals. So this function can be used by this class and its subclasses, unlike functions that starts with double underscore, which are private. So let's use this function. If self dot underscore verify underscore pin, parenthesis, pin, column, new line, return, self dot double underscore balance. Let's copy these two lines in the other function and paste. And let's change the variable underscore account underscore type. And now let's create an object. Account equal bank account parenthesis quotation marks Alice, comma 1000. Let's set the pin. Account dot set underscore pin parenthesis 1111 new line print parenthesis f string public attribute column curly brackets account dot account holder new line print parenthesis f string protected attribute column curly brackets account dot get underscore account underscore info parenthesis 1111 new line print parenthesis f string private attribute column curly brackets account dot get balance parenthesis 1111 and let's run it. And as you can see, we printed a public attribute, which is Alice. We printed a protected attribute, accessing it using a public function. And then we printed a private attribute, accessing it from another public function. Now let's try to do the same thing from the subclass, but this time we'll show the alternative way to access the protected attribute and method. Let's first copy this function, which contains the protected attribute and the protected method, and paste it. Let's change the name underscore from underscore subclass. And now let's create the object sub underscore account equal savings account parenthesis quotation marks Bob comma 1200 new line sub underscore account dot set underscore pin parenthesis 2222. Let's copy these three lines and let's change the pin. The name of the function underscore from underscore subclass, and let's change the name subaccount, subaccount, and subaccount. And as you can see, we got the same result, but this time from the subclass. So let's recap. In this lesson, we learn about encapsulation, and we learn how to create a public, a protected, and a private attribute and method. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about another fundamental principle of object-oriented programming called polymorphism, which allows objects of different classes to be treated as objects of a common superclass. Let's get started. Let's create a subclass, class, circle, parentheses, shape, column, new line, def, double underscore, init, double underscore, parentheses, self, comma, radius, column, new line, self dot radius equal radius, new line, def, area, parentheses, self, column, new line, return 3.14 multiplied by self dot radius, double asterisk 2. And let's create another subclass, new line, class, rectangle, parentheses, shape, column, new line, def, double underscore init, double underscore, parentheses, self, comma, width, comma, height, column, new line, self dot width equal width, new line, self dot height equal height, new line, def, area, parentheses, self, column, new line, return, self dot width multiplied by self dot height. And let's create the instance of these two objects. Circle equal circle, parentheses 5, new line, rectangle equal rectangle, parentheses 2, 3. And let's create also a shape, new line, shape equal shape, parentheses, new line. Let's combine in a list, shapes equals, square brackets, circle, comma, rectangle, comma, shape. New line, 4, as in shapes, column, new line, print, parentheses, f string, area, column, curly brackets, s dot area, backslash n, new line, f string is a shape, column, curly brackets, is instance, parenthesis, s, comma, shape, backslash n, f string is a circle, column, curly brackets, is instance, parenthesis, s, comma, circle, backslash n, new line, f string is a rectangle, column, curly brackets, is instance, parenthesis, s, comma, rectangle, backslash n, and let's run it. And as you can see, every object we instantiated is at least a shape. If it's a subclass, it's also another instance, a circle or a rectangle. So using polymorphism, you can treat all the subclasses as they are the same class. Now let's recap. So in this lesson we learned how to use polymorphism to manage different classes at the same time. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about another fundamental principle of object-oriented programming called abstraction, which allows us to create interfaces which acts as a contract, ensuring that all subclasses follow a common structure. It cannot be instantiated directly and defines a set of methods that must be implemented by any subclass. So starting from what we did in the last lesson, let's make the shape class abstract, inserting ABC. And then let's make also his method abstract using a decorator, add abstract method. Let's remove this part. Let's create another abstract method, add abstract method, def, perimeter, parenthesis, self, column, line, pass. And now let's implement this new method in the subclasses, def, perimeter, and let's 3.14 multiplied by self dot radius multiplied by 2. Let's implement this method in the other class, def, perimeter, 2 multiplied by parenthesis, self dot width plus self dot height. So we overrided the area and perimeter methods from the abstract class. Now let's instantiate two objects from these subclasses. Shapes equal, square brackets, circle, parenthesis, 3, comma, rectangle, parenthesis 4, 5. New line for shape in shapes column, new line, print, parenthesis, f string, curly brackets, shape dot, double underscore, class, double underscore, dot, double underscore, name, double underscore. Area, column, curly brackets, shape, dot, area. New line, print, parenthesis, f string, curly brackets, shape, dot, double underscore, class, double underscore, dot, double underscore, name, double underscore, perimeter, column, curly brackets, shape, dot, perimeter, parenthesis, and let's run it. And as you can see, we have been able to use these subclasses by implementing the interface and overriding all of its abstract methods. Now let's recap. So we learned how to use abstraction to create abstract class, abstract method, and interface. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about static methods. These are methods inside a class that can be used without needing to instantiate an object. So let's get started. First of all, let's create a class, string, manipulator. Column, new line, at static method. By using this decorator, we are declaring that the method following it can be used without creating an instance of the class. Now let's declare the method def reverse underscore string parenthesis s. And as you can see, we don't need to use the self parameter for a static method. New line, return s, square brackets, com, -1. Let's create another method, at static method, def count underscore vowels, parenthesis, s, column, new line, vowels, equal, all the vowels, new line, return, sum, parenthesis, 1 for char in s if char in vowels. New line, at static method, def remove underscore symbols, parenthesis, s, column, new line, return, quotation marks, dot, join, parenthesis, char for char in s if char dot is all num, parenthesis, or char dot is space, parenthesis, new line. And now we don't need to instantiate an object to use this method, so Let's create a string to test. String equal quotation marks hello world. Let's put some symbols and numbers. New line, print, parentheses, string manipulator dot reverse string, parentheses, string. New line, print, parentheses, string manipulator dot count vowels, parentheses, string. New line, print, parentheses, string manipulator dot remove symbols, parentheses, string. And let's run it. As you can see, it works. So you are not really forced to use the @static method decorator, but it's a good practice when the method doesn't need to access or modify the instance, the self. In this way, it clearly signals how the method should be used. Now let's recap. We learned what a static method is, and we saw how to declare it using the @static method decorator. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about data classes, which are useful for quickly and easily creating blueprints for instantiating objects. So let's get started. Data class, new line, class, point, column, new line, x, column, int, new line, y, column, int, equal 0. And let's create an object, p1 equal point, parentheses, 3, 4. New line, print, parentheses, p1. As you can see, we have been able to create an object and print it easily. Now let's add also a method to this class. Def distance underscore to parentheses self comma other column new line return met dot sqrt parentheses self dot x minus other dot x double asterisk 2 plus parentheses self dot y minus other dot y double asterisk 2. Let's create another object, p2 equal point parentheses 2 comma 2 print parentheses p1 dot distance to parentheses p2, and let's run it. As you can see, we obtain the distance between these 2 points easily. Now let's use another decorator @property new line def distance underscore from underscore origin parentheses self column new line return mat dot sqrt parenthesis, self dot x double asterisk 2 plus self dot y double asterisk 2. And let's print the result. Print parenthesis p1 dot distance from origin. Because we use the decorator, we don't need to use the parenthesis, and we can call it as it was an attribute of this data class. Now let's recap. So we learn how to create and use a data class and how to use the property decorator. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to build a tower defense game. It's a long project, so today I'll only show a small part of the development. And now I'll show you what I already created. So I first created a button class, since we'll be using many buttons throughout the project. I also defined several constants, such as grid, which represent the path enemies will follow from the start to the end. The enemies will walk only on grid cells with values greater than 0, forming a continuous line from the 2 to the 3, the end. Then I created an enemy class. This one was quite challenging. It's not a small or simple class, but it contains everything needed for the enemies to move across the grid. I added a message box class to display messages when the player either wins or loses the game. The projectile class, it's very simple and contains the logic for removing life from enemies when they are hit. Of course, we have a tower class, which handles tower creation and attacking enemies. I also created a tower.ini file to make it easy to create as many tower types as we want. I created just 3 towers. I created also some images using the tool we created in the lesson 10. And I downloaded the other images from a site. I'll put the link on the description. Then I create also a level.ini file, which is very useful. You can define enemy strengths, assign their images, and create multiple levels, as many as you want. I've created 5 levels for this tutorial. And then there is the main file, which contains helpful functions such as drawing the grid, reading the config file, drawing game stats, and getting specific towers, which will be very useful in what I'll develop today. Here we instantiate the user interface. These 3 elements are a sort of lists which can manage many elements. This one is to know if the game has started, if it's running, if the level is running, if you select the tower, which is the current level, and the enemies. These one are the statistics for the game. Here to get the towers and the levels. Here a set to decide how many times you can update a tower. And here the towers button, and a button to start the game, and to sell and upgrade the tower. And here the the main loop, which is going to be for the duration of the entire game, and we are going to just create this part. So now we are going to create the virtual environment. So let's open a terminal. Let's use the command prompt. And let's create the virtual environment. Python -m venv.venv. And then let's activate the environment /venv /scripts /activate pip install pygame. Let's check the installation. Perfect. Now let's activate the virtual environment also on the Visual Studio Code, if it's not, and let's start. For event in pygame dot event dot get parenthesis column new line if event dot type double equals pygame dot quit column new line game underscore running double equal false. Elif event dot type double equal pygame dot mouse button down column new line if button underscore start dot is clicked parenthesis event and not level underscore running column new line level underscore running equal true. Total underscore enemies spawned equal 0. New line enemies dot empty parenthesis new line spawn underscore fire underscore rate comma enemy health comma speed comma value comma enemy underscore image comma num underscore enemies equal levels square brackets current level -1. So we are setting the properties of our enemies. Line elif button underscore tower 1 is clicked parenthesis event column new line selected tower equal quotation marks tower 1. Let's copy these lines and let's paste them twice. Let's change the numbers. 3, 3, 2, and 2. In this way, we are managing the opportunity to build new towers after we click the buttons. If button underscore cell dot is clicked, parenthesis, event, and selected tower and is instance, parenthesis, selected tower, comma, tower, column. So if we click a tower that we want to sell, money plus equal int, parenthesis, round, parenthesis, selected tower, dot cost, multiplied by 0.9, grid, square brackets, selected tower, dot rect, dot y, divided by cell size with the integer divider, of course. Square brackets, selected tower, dot rect, dot x, double divider, cell size, equals 0. Because as we say, the zeros are the empty square. Towers that remove, parenthesis, selected underscore tower, selected tower equal none. Elif button underscore upgrade that is clicked, parenthesis, event, and selected tower, and is instance, parenthesis, selected tower, comma, tower. Again, we need to be sure that we clicked on an actual tower and not on a button tower. If money bigger or equal than selected tower, that upgrade cost, and selected tower dot level smaller than max underscore tower underscore level, column, new line, money minus equal, selected tower dot upgrade cost. New line, selected tower dot level plus equal 1. Selected tower dot range equal int, parenthesis, round, parenthesis, selected tower dot range multiplied by parenthesis 100 plus selected tower dot level multiplied by 3 divided by 100. Of course, I made up this increment, so you can do whatever you want. For simplicity, we'll apply this to all the statistics of a tower, so let's change fire underscore range, fire underscore range, fire underscore rate, fire underscore rate, upgrade cost, and cost. So this is what will happen if you can't afford an upgrade on a tower. New line, if event dot button double equals 1. This part will control if you click something that it's not one of these buttons. So if you click on an empty grid, but we'll think about it in a few. Now let's start to building a bit of the logic of the game. So pass, new line, if level underscore running, column, new line, for tower in towers, column, new line, projectile equal tower dot update, parenthesis, enemies, new line, if projectile, column, new line, projectiles dot add, parenthesis, projectile. So we generated a projectile for enemy in enemies, column, new line, if enemy dot progress underscore path, parenthesis, enemy dot find path, parenthesis, grid, column, new line, lives minus equal 1, new line, enemy dot kill, parenthesis, if enemy dot health minor or equal than 0, column, new line, enemy dot kill, new line, score plus equal 10, new line, money plus equal value. So we build the two things that could happen, or the enemy achieve the end of the path, or its health is less than 0, so we removed one of them. New line, projectiles dot update, if total underscore enemies underscore spawned less than num underscore enemies, column, new line, spawn underscore counter plus equal 1, new line, if spawn underscore counter greater or equal than spawn underscore fire underscore rate, column, new line, spawn counter equal 0, new line, enemies dot add, parenthesis, enemy, parenthesis, enemy health, comma, speed, comma, value, comma, enemy image, new line, total enemies spawned, plus equal 1. So this part take care of almost all the logic behind the battle between the towers and the enemies. Now let's draw the grid. Draw underscore grid underscore elements, parentheses, screen, comma, towers, comma, enemies, comma, projectiles. New line, if not lever underscore running, column, new line, button start dot text equal f string start level, curly brackets, current level, new line, button start dot draw, parentheses, screen. We draw the start button, new line, score underscore text equal font dot render, parentheses, f string score column, curly brackets, score, comma, true, comma, blank. New line, money underscore text, font dot render, parentheses, f string, money, column, dollar symbol, curly brackets, money, comma, true, comma, black. New line, leaves underscore text equal font dot render, parentheses, f string, leaves, column, curly brackets, leaves, comma, true, comma, black. New line, screen dot blit, parentheses, score underscore text, comma, parentheses, 10, comma, 590, new line, screen dot blit, parentheses, money underscore text, comma, parentheses, width divided by 2 minus 90, comma, 590, new line, screen dot blit, parentheses, lives underscore text, comma, parentheses, width minus 130, comma, 590. New line, button underscore tower dot draw, parentheses, screen. Let's copy this line twice. 3, 2, new line, if level underscore running, total enemies spawned double equals num underscore enemies and len, parentheses, enemies double equals 0, column, new line, level underscore running equal false, new line, current underscore level plus equal 1, new line, And then let's check for a win or a lose. New line. If current underscore level bigger than len parenthesis levels, column, new line, message box equal message box parenthesis screen, comma, quotation marks, you win, comma, f string, final score, column, curly brackets, score, multiplied by leaves, multiplied by money. If message underscore box dot show parenthesis column new line game underscore running equal false. Let's copy these lines and let's make the loose variation. If lives smaller or equal than 0, you lose. And here remove lives. Okay. Let's add also the clocks by game dot display dot flip parenthesis new line clock dot tick parenthesis 60. And let's try, I think we can't interact, but we should see the enemies walk. Start level. Okay, it looks pretty good. The score, the money, the enemies. Now we should lose all the leaf. Okay, we get the message box. You lose. Okay. Now let's add the interaction with the grid. Remove path x, comma y equal pygame the dot mouse dot get pose parenthesis new line if y less than cell underscore size multiplied by len of grid column new line grid underscore x comma grid underscore y equals x divided by cell underscore size comma y divided by cell underscore size new line try if grid square brackets grid underscore y square brackets grid underscore x double equals 0 column new line if selected tower double equals quotation marks tower 1 and money greater or equal than type underscore towers square brackets 0 square brackets 4 column new line towers dot add parenthesis get underscore tower parenthesis grid underscore x, comma, grid underscore y, comma, type underscore towers, comma, 0. Money minus equal, type towers, square brackets, 0, square brackets, 4, which is the cost. New line, grid, square brackets, grid underscore y, square brackets, grid underscore x, equal 4. Now let's copy these 4 lines and let's change the numbers. 2, 2, and 2. For the towers, 3, and 1, 1, and 1 for the tower 2, because we created 3 towers, as you remember, in the tower.ini file. elif new line, except index error as e column, new line, print, parenthesis, f string, error, column, curly brackets, e. New line, for tower in towers, column, new line, if tower dot rect dot collide point, parenthesis, event dot pose, column, new line, select underscore tower, equal tower, break, else selected underscore tower equal none. New line, else selected underscore tower equal none. This way we can deselect a tower. So now we should be able to put towers on the grid. So let's try to do it. So the tower, another, another. Let's try to run the first level. Okay, it works. They fire. And we are not able to see their statistics, so we have just to draw the statistics. It works pretty good so far. So let's close it. And then let's draw the statistics. Let's put the statistics before the message box here. If selected underscore tower and is instance parenthesis selected underscore tower, comma, tower, column, new line, by game dot draw dot rect parenthesis screen, comma, gray, comma, parenthesis width minus 350, comma 455, comma 350, comma 130. New line. So we drew a rectangle. Draw underscore tower underscore stats parenthesis screen selected tower, comma selected tower dot level, comma selected tower dot range, comma selected tower dot file range, comma selected tower dot file rate, comma selected tower dot cost, comma selected tower dot upgrade cost, comma max underscore tower underscore level. In this way we can draw the statistics of an actual tower on the grid. If selected underscore tower dot level less than max underscore tower underscore level, column, new line, button underscore upgrade dot draw, parenthesis, screen, new line, button underscore cell dot draw, parenthesis, screen, new line, pygame dot draw dot circle, parenthesis, screen, comma grid gray, comma selected underscore tower dot rect dot center, comma selected underscore tower dot file range, comma 1, new line. Now let's draw the statistics of the button for I in range, parenthesis, len, parenthesis, type underscore towers, column, new line, if selected underscore tower, double equals, f string, tower, curly brackets, I plus 1. Column, new line, pygame dot draw dot rect, parenthesis, screen, comma, gray, comma, parenthesis, width, minus 350, comma 455, comma 200, comma 130. New line, draw tower stats, parenthesis, screen, selected tower, comma type underscore towers, square brackets, I, square brackets, 0, comma. Now let's copy this line 5 times. Let's change the index. 5, 4, 3, 2, and 1. Max underscore tower underscore level. And that's it. We can run the the full program and try to win the game. Let's put a tower. Let's try to upgrade the 5th level. Perfect. Let's take another tower. Let's try to upgrade. Okay, perfect. We can't do anything more. Okay, let's start the level 2. It looks harder. I don't know if oh. Okay, let's start level 3. And now we try to build our 3rd tower during the level. Okay, start another level. And we'll upgrade the tower as soon as we could. Okay, we're doing pretty good. Now let's try to sell a tower. And also this one. And let's put the strongest. Let's upgrade. Let's put another. And let's upgrade it. Okay. I think we'll sell the first tower. Okay. Sell. And we put another one. Oh, perfect. So for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys. In this lesson we are going to learn how to use Git and GitHub to track the progress of a program and save it in an online repository, making it easy to share with others. So let's start. Let's open our terminal. Let's select Command Prompt. Let's create a virtual environment. Python -m venv.venv. In this program we are going to use the joke API, which allows us to fetch random jokes easily. Let's activate the environment /venv /scripts /activate. And then let's install a module pip install request. Let's activate the virtual environment if it's not already activated in your code editor. And let's create the requirements file pip freeze greater than, requirements, .txt. And now let's use git. In my case, we are going to use git from the command line to initialize our repository. Git init. Using git init, we initialize our repository. But as you can see in the Explorer, all the files are marked as untracked. So now we need to add the ones we want to track. Git add main.py. As you can see, it could be a bit time consuming to add files one by one, so we have a way to do this faster by creating the .gitignore file. Everything written in this file will be ignored by Git. So, first of all, let's add the double underscore, pycache double underscore, slash, new line, then the virtual environment, .venv slash. Let's save the file. And as you can see, the folder with that name, in this case the .venv folder, becomes gray. It means it will not be tracked. New line, .vscode slash. Let's save the file and then back to the terminal. Git add dot. Now all the files we want to keep track of have been added to Git. But we are missing one last step. And before that step, we have to do this one-time configuration to add our username, which in my case will be the same as my GitHub profile. Git config -- global user.name, double quotation marks, and your username. Git config -- global user.email, double quotation marks, and your email. Then we can proceed with the last step to create a sort of snapshot of the current state of our program. Git commit -m, double quotation marks, initial commit. And as you can see, everything has been done. The files are white now. Let's check git log. And as you can see, here we can find all the commit we made. And here there is just our initial commit. So let's add some code. Settings equal get underscore settings, parentheses, save underscore jokes, parentheses, settings dot get, parentheses, quotation marks, file name, comma, quotation marks, jokes, dot csv. Comma, URL. Then up here, writer dot write row parentheses square brackets datetime dot now parentheses dot ISO format parentheses time spec equal quotation marks seconds comma get underscore joke parentheses URL. Now let's try to run this program. It should generate a CSV with a joke downloaded using our IPA. Okay, let's check. Here's the file and here is the joke with the timestamp. As you can see, the file is green because it's not added to Git. We don't want to add this to Git, so let's add a new line on the git ignore file. Asterisk dot CSV. This way we avoid tracking all .csv files. Now let's commit again. Git commit -a make program fully functional. Save and close it. Let's check again. Git log. Press enter to scroll. You can see all the commits you made and Q to quit. Now let's make it possible to download as many jokes as we want at once. Let's open the config file. Count equal 3. Let's add count up here. Comma, count. And a loop here for underscore in range parentheses count column let's add the parameter here int parentheses settings dot get parentheses quotation marks count comma 1 comma, and now let's run it again. Let's open the CSV, and as you can see we update 3 more jokes, so let's commit again. Git commit -a add support for multiple jokes. Let's close and save. Let's check it. Git log. So all the commits we made are here, and now we have to learn how to use GitHub in order to share our program easily. So go to GitHub, click on repositories, and click New. Let's give it a name, git_test. Let's ignore everything else and click on Create Repository. Then, to push our code to GitHub, copy the link from the top by clicking the copy button. Then go back to the terminal and run git remote add origin, and let's paste the link, push enter, and then git push -u origin master. Press enter and go back to your browser and press F5 to refresh the page. And as you can see, here are all the files we wanted to keep track of and the related commits we made. Let's click on main.py to check. As you can see, it's exactly as we made it. Now let's recap. Lesson 21 -git and GitHub. So in this lesson we learn how to use git and many commands like init, add, config, commit, log, remote, and push. And we also learned how to create a repository on GitHub. So for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about logs and how to use the logging module. Logs are messages that your program writes during execution to help you track its behavior, debug issues, and monitor its status. So let's get started. First of all, we need to set up the logging file. So log_path equal os.path.join parentheses log_dir, comma, log_file. New line, os.makeDirs, parentheses, log_dir, comma, exist_ok equal true. New line, handler equal rotating file handler, parentheses. This allows us to write logs to a file and automatically creates a new file when the current one gets too big. New line, log_path, comma, new line, max bytes equal 512, comma, backup count equal, let's say 3. In this way, we are going to create a maximum of 3 backups every time the size of the log file exceeds max bytes. New line, formatter equal logging.formatter, parentheses, %, parentheses, ask time s. hyphen, percent symbol, parenthesis, level, name, s, hyphen, percent, parenthesis, message, s. In this way we are formatting the message that is going to appear on the log file. New line, handler dot set formatter, parenthesis, formatter. New line, logger equal logging dot get logger, parenthesis, new line, logger dot set level, parenthesis, logging dot info, new line, logger dot add handler, parenthesis, handler. Calling this function allows us to easily use and store logs from our program. Now let's add some logging to this class bank account, logging.info, parenthesis, fstring, account for, curly brackets, owner, created with dollar symbol, curly brackets, balance. Let's add another log, logging dot info, parenthesis, fstring, curly brackets, self dot owner, deposit, dollar, curly brackets, amount, parenthesis, balance, column, dollar symbol, curly brackets, self dot balance. We can create also other types of logs, so let's do it. Elif amount double equals 0, column, new line, logging dot warning, parenthesis, fstring, deposit must be bigger than 0. Else, column, new line, logging dot error, parenthesis, fstring, deposit can't be negative. Now let's add also to the withdraw function elif amount less or equal than 0, column, new line, logging dot warning, parenthesis, fstring, withdraw must be greater than 0. New line, elif amount bigger than self dot balance column new line logging dot error parenthesis f string you can't withdraw dollar curly brackets amount. Now let's try to run this program and see what's happened. So we generated the logs folder and the bank.log file. Let's run it again to generate also the backups. As you can see, other 4 lines. Let's run it again. Okay, and as you can see, we generated also the backup. So here are the most recent logs, and in the backup files, you can find the older logs. Now let's recap. Lesson 22 hyphen logging. We learn about the module logging and how to use a rotating file handler to manage the size of the logs. And we learn how to use info, error, and warning. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about JSONs, which are a very practical solution used in many ways, mainly for creating configuration files, saving complex data structures, and sending and receiving messages on the internet. So let's get started. First of all, let's create a dictionary, user_1 equal, curly brackets, new line, quotation marks, ID, column 1, comma, new line, quotation marks, name, column, quotation marks, red, comma, new line, quotation marks, is_student, column, true, comma, new line, quotation marks, courses, column, square brackets, quotation marks, Python, comma, quotation marks, science. And now let's create the function to write a JSON to a file so we can see how it is. With open parenthesis file name, comma, quotation marks, W as file, column, new line, JSON dot dump parenthesis data, comma, file, comma, indent equal 4. Then let's call this function write to JSON file, parenthesis, user_1, comma, quotation marks, user.json. And let's run this program. As you can see, here is the JSON, which is almost identical to a regular Python dictionary. And so that's how JSON are structured. But what if there is more than one dictionary? Let's do it. So let's copy this user and let's create another one. User 2, ID 2, let's say Bob, let's say false, and let's change science into history. Now let's create a list of users. Users equal square brackets user underscore 1, comma, user underscore 2. New line, write JSON to file, parentheses, users, comma, quotation marks, users, dot, JSON. And let's run the file again. And as you can see, in this case, it's a big list of dictionary. So JSON are very versatile. So as I said, JSON are also used as config file. And as you can see in the Explorer, there is a config.json. So let's read it with open parentheses, file name, comma, quotation marks, R, as file, column, new line, data equal, JSON dot load, parentheses, file, new line, return, data. Let's assign this function to a variable, config equal read JSON from file, parentheses, quotation marks, config.json. New line, print, parentheses, type, parentheses, config, comma, config. And let's run it. And as you can see, in that JSON there is only one dictionary with only one element, which is a URL, which allows us to test and practice working with fake online REST APIs using JSON data. And we are going to use the CRUD methods. CRUD is an acronym that stands for create, read, update, and delete, the fundamental actions used to manage a database. We'll perform these actions using the corresponding HTTP methods, which are post, get, put, and delete. So print, parentheses, f-string, post, colon, curly brackets, create underscore article, parentheses, config, square brackets, quotation marks, URL, comma, quotation marks, news, quotation marks, comma, quotation marks, JSON. So we are going to create a record, then new line, print, parentheses, f-string, get, colon, curly brackets, read articles, parentheses, config, square brackets, quotation marks, URL. New line, print, parentheses, f-string, put, column, curly brackets, update article, parentheses, config, square brackets, quotation marks, URL, comma, 1, comma, quotation marks, new title, comma, quotation marks, new content. New line, print, parentheses, f-string, delete, quotation mark, column, curly brackets, delete article, parentheses, config, square brackets, quotation marks, URL, comma, 1. And let's run it. So, using this method, as we did, is similar to changing data in a remote server's database, which is what happens indirectly almost every time we interact with a web page on the internet. So let's recap. Lesson 23-JSON. We learn how to use the JSON module. We learn how to use the CRUD methods. And we learn the use of the corresponding HTTP methods: post, get, put, and delete. For this lesson it's enough. Thanks for watching, and see you in the next lesson. Hi guys, in this lesson we are going to use environment variables, which are values stored outside the code, often used to keep configuration setting and sensitive data, especially sensitive data. So let's get started. I already created and activated the virtual environment. We just need to import another module, which is pip install python-.env. This module makes it easier to manage sensitive data securely. Now let's create the requirements. Pip freeze greater than requirements.txt. Then we have to create a .env file. You must call it in this way. And then you have to add these informations in the same way I did, except you have to put your email and your password email. The other two parameters are mail dependent, so I'll post in the description the correct version for different mail. And I suggest you to don't use Gmail because you have some more work to do that I can't show you. And after we create the .env file, we have to create the gitignore file. And let's add double underscore pycache double underscore slash new line .venv slash new line .vscode slash new line and the .env file. Let's save it and let's initialize our repository git init. Git add dot git commit -m double quotation marks, initial, commit. And as you can see, we can keep our password securely. Now that we did this, we want to create a sort of mail sender automation, so let's do it. MSG equal email message, parentheses, new line, MSG, square brackets, quotation marks, from equal host dot get env, parentheses, quotation marks, email underscore address. New line, MSG, square brackets, quotation marks, to equal to address, new line, MSG, square brackets, quotation marks, subject, equal, subject, new line, MSG, dot, set content, parentheses, body, new line, with smtp lib dot smtp, parentheses, os dot get env, parentheses, quotation marks, smtp underscore server, comma, init, parentheses, os dot get env, parentheses, quotation marks, smtp underscore port, as smtp, column, new line, smtp dot start tls, parentheses, new line, smtp dot login, parentheses, os dot get env, parentheses, quotation marks, email underscore address, comma, os dot get env, parentheses, quotation marks, email underscore password, new line, smtp dot send message, parentheses, msg, and this should be enough, so let's run it. And as you can see, I auto send an email to my account, and that's enough, so let's recap. Lesson 24 hyphen environment variable. We learn how to use the .env file and how to use the .env module to load securely sensitive information. For security, remember to remove the password from the .env file. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about asynchronous functions using async and await, which allow a task to take its time while other processes running, speeding up the overall program. So let's get started. First of all, let's install a useful module, pip install tqdm, and then let's create the requirements file pip freeze greater than requirements.txt. Okay, now first of all we can import our file, import synchronous, and let's call a function from that file, synchronous dot run sync pipeline parenthesis shared delays comma steps per task. Let's save it and open the file. So in this file there are three functions. One, which is the one we called from the main file, print some things, some details, and then take the starting time, call a function, and then take the end time and print the executed time. Then there is the function, which we call from that one, which call three times another function that we are going to code. So let's do it with tqdm parenthesis total equal steps comma desk equal name comma position equal int parenthesis name square brackets -1 -1 comma leave equal false. As p bar column new line 4 underscore in range parenthesis steps column new line time dot sleep parenthesis delay new line p bar dot update parenthesis 1. In this way we are calling this function with different delays, simulating different tasks that take different times to update. And using the tqdm function, we are able to show the difference in execution time visually. So let's try to run the main file. Okay, has been pretty fast. As you can see, the delays were really small, but you can appreciate the difference in execution time. And what we want to do is to create another file where we can run these functions asynchronously, so they can run concurrently. In this way, you'll see a big improvement in time duration using asynchronous function instead of synchronous function. So let's do it. Let's open the synchronous file, select everything, and then copy. Let's create a new file, asynchronous .py. And then let's paste everything. Now we have just to make some small changes. First of all, let's import async IO. And then let's start from the function we'll call from the main. So async IO dot run parenthesis and close the parenthesis. This one is the only adjustment we are going to make to this function, except the sync that will be async. Then we have to make this function async in order to use await inside this one. So async and then await async io dot gather parenthesis task underscore 1 comma task underscore 2 comma task underscore 3. And now we want to make also the other function async, so async, and then instead of time.sleep we are going to use await async io, and that's it. Now let's change the sync into async everywhere, sync, asynchronous, and then here async. Let's save it and open the main file. Let's import asynchronous, and let's call the function asynchronous dot run underscore async underscore pipeline parenthesis shared delays comma steps per task. And now let's run it. Okay, bigger delays. Total time 13 seconds. Instead of just 5 seconds. Using asynchronous function has been a big advantage in terms of time. So let's recap. Lesson 25 hyphen async await new line. We learn how to use async and await and some function of tqdm and async io. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about databases, which are a widely used method for storing data. To work with databases effectively, you need to know SQL, the language used to manage and manipulate them. That's why in this lesson we'll also write a bit of SQL to get some hands-on experience. So let's get started. First of all, we have to create the database. So con equal SQLite3 dot connect parenthesis quotation marks contacts dot db. You have also to close the connection. So con dot close parenthesis, and let's run it. And as you can see, there is a new file in the Explorer, which is the database, which is empty. So now let's create a table inside of this database. Cursor equal con dot cursor parenthesis. Let's close also this. Cursor dot close parenthesis. And now let's call the function to make the table. Make contacts table parenthesis cursor comma con. And then we have to write the query using SQL inside these 3 quotation marks. Create table if not exists. Contacts, parentheses. We are using capital letters because they are commonly used to indicate SQL keywords. ID, integer, primary key, auto increment, comma, new line, name, text, comma, new line, phone, text, comma, new line, email, text, comma, new line, address, text, comma, new line, created at, datetime, default, current underscore timestamp, comma, new line, active, integer, default, 1. And let's run it. And let's check the database. And as you can see, we have tables. In particular, we have our table, which is contacts, with all the columns we just created. Now let's try to use the CRUD methods to manipulate this table. So create underscore contact, parentheses, cursor, comma, con, comma, quotation marks, red, comma, quotation marks, 1, 2, 3, 4, 5, 6, comma, quotation marks, red at mail.com, comma, quotation marks, London. Let's create also another record, create underscore contact, parentheses, cursor, comma, con, comma, quotation marks, t, comma, choo-choo, 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 comma, quotation marks, t at mail.com, comma, quotation marks, Paris. And now let's create the query for create new contacts. Insert into contacts, parentheses, name, comma, phone, comma, email, comma, address, comma, active. New line, values, parentheses, question mark, comma, question mark, comma, question mark, comma, question mark, comma, question mark. All these question marks will be replaced with what's inside this tuple, parentheses, name, comma, phone, comma, email, comma, address, comma, active. And so let's try to run the program. And let's check the database. And as you can see, 2 records has been added, which are what we expect. Also the active, okay, that's everything. So let's try to read what's inside the database using another query. Select, asterisk, new line, from, contacts. Let's call this function. For C in read contacts, parentheses, cursor, column, new line, print, parentheses, C. And let's run it. And as you can see, we printed 4 records because running again the program added another 2 records, which are almost the same except for the ID and the timestamp. So now let's call another road method, which is the update contact, parentheses, cursor, comma, comma, then the ID we want to change, 3, comma, quotation marks, Bob, comma, quotation marks, 333333, comma, quotation marks, bob@mail.com, comma, quotation marks, Berlin, comma, 1. Let's create the query to update the ID equal 3 of the table. New line, update, contacts, new line, set, name equal question marks, comma, phone equal question mark, comma, email equal question mark, comma, address equal question mark, comma, active equal question mark, new line, where ID equal quotation mark. So the ID has to be placed at the end of the tuple because the question marks are replaced in order. So the first has to be name, comma, phone, comma, email, comma, address, comma, active, comma, ID. So in this way it should work. So let's run the program again. And as you can see, the third record has turned into Bob. So now let's try to delete a contact. Let's create the query, delete from contacts, where ID equal question mark. Parentheses, ID, comma. Now let's call the function. New line, delete contact, parentheses, cursor, comma, comma, 1. So we are going to remove the first record. Let's run again the program. Let's check if the 1 is missing. As you can see, we removed the first record, which is the record with the ID equals to 1. Now let's recap. lesson 26 hyphen database. Learn how to use SQLite tree in order to create a database, a table using SQL. So for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to learn how to calculate the time and space complexity of different functions. We'll look at some typical examples that will help you understand how to analyze performance in real code. Time complexity helps us estimate how much longer a function will take to run as the input gets bigger. Space complexity tells us how much memory a function uses as the input size grows. So let's get started. Here we have this little function, as you may see. There is just one number and one expression with no loop, so n equal 1. So f of n is equal to 1. So big O of 1 for the times complexity and big O of 1 for the space complexity. Big O notation is used to describe the upper bound of a function's time or space complexity as the input size increases. So this is a very simple example. It doesn't help so much to understand, so let's see something more complex. In this function there is a loop. So n in this case of the time complexity is equal to the length of the list. So f of n it's equal n. So the big O notation is big O parenthesis n for the time complexity, and it's again 1 for the space complexity. Now I want to point out something. Let's add items dot extend parenthesis items. If the list items was double the size, would that change the time complexity? The answer is no. You might think the function becomes 2n, but big O notation only cares about the rate of growth. Constants are dropped, so it remains big O of n, also in this case. Now let's see another example. Again, another loop. So again, n is equal to length of items, but there is a small difference in the space complexity. So f of n it's equal to n. So big O it's n again for the time complexity, but in this case is also big O of n for the space complexity. Because as you can see, here we append item by item till the end of items, so the big O notation is n also for the space complexity. Nothing else to say about this. Here we have a nested loop, which is a bit more complex. Let's analyze one by one. So n equal length of items. Let's say this. And then there is n1, which is the first loop. Let's name it n1 and n2. n1 equal to n, okay? n2 equal n divided by 2, That's because n2 is a bit different. It starts at I plus 1 and goes to the end, so it runs about n divided by 2 times. F of n, it's equal to n1 multiplied by n2, which is equal to n squared divided by 2. So, what is the big O notation? N squared. So, big O of n squared for the time complexity, and O of 1 for the space complexity. We are not occupying any space. Now let's look at this next function. Here we check if a number is a perfect square using a loop. We go through values of k such that k multiplied by k has to be smaller or equal of n. So how many times do we loop? Well, if n equal 1, which is equal to 1 squared, then n equal 4, which is 2 squared. Then n is equal to 9, which is 3 squared. And so on. As you can see, the pattern is n equal k squared. So, square root of n, it's equal of k, which means that the big O, it's square root of n for the times complexity, and again 1 for the space complexity. Big O, 1. Space. Now let's take a look to the last example. In this case, n is divided by 2 until it's equal to 1. So n divided by 2 equal n divided by 2 raised to the power of 1, and n divided by 4 equal n divided by 2 raised to the power of 2. Then n divided by 8, it's equal to n divided by 2 raised to the power of 3. And so on. Again, the pattern, it's n divided by 2 raised to the power of k, which, as we said, we stop when n divided by 2 raised to the power of k equal to 1. So n equal 2 raised by k, which is equal to log of n equal to log of 2 raised by k, which is log of n in base 2 equal to k, which means that big O, parenthesis, log of n for the time complexity, and again big O of 1 for the space complexity. Let's recap. Lesson 27-algorithm. we learned how to measure time complexity and space complexity, and how to express this using big O notation. So for this lesson, that's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about data structures that we didn't discuss before. By data structure, we mean a way to organize and store data so that it can be accessed and modified efficiently. So let's get started. V1 equal bytes, parentheses, square brackets, 72, comma, 101, comma, 108, comma, 108, comma, 111. New line, print, parentheses, type, parentheses, B1, comma, B1. And let's run it. As you can see, we created our first object of type bytes, which is very similar in many aspects to a tuple because it's an immutable collection of elements. So let's try doing something with this bytes object. Print, parentheses, B1, square brackets, 0. Line, print, parentheses, B1 dot find, parentheses, B, quotation marks, O. And let's run it. As you can see, we printed the first element of the collection and we also printed the index of the element we wanted. Now let's try to create another bytes object. B2 equal B, quotation marks, hello world. New line, print, parentheses, type, parentheses, B2, comma, B2. And let's run it again. And as you can see, we created another bytes object. Now let's use the bytes function to convert a string. S1 equal, quotation marks, Python. New line, B3 equal, bytes, parentheses, S1, comma, quotation marks, UTF, hyphen, 8. New line, print, parentheses, type, parentheses, B3, comma, B3. So it works. Now let's explore the next topic, byte array, which contains the same type of data as bytes object, but is mutable and manageable like a list. So B equal byte array, parentheses, square brackets, 72, comma, 101, comma, 108, comma, 108, comma, 111. New line, print, parentheses, type, parentheses, B, comma, B. As you can see, that's our first byte array. So let's try to update it. B, square brackets, 0, equal 74. Print, parentheses, B. And as you can see, we changed the first letter. New line, B dot append, parentheses, 33. New line, print, parentheses, B. And as you can see, we added an element to this collection. So new line, B dot pop, parenthesis, new line, print, parenthesis, b. And using pop, we removed the last element. b dot extend, parenthesis, b. New line, print, parenthesis, b. As you can see, it is very similar to a list. Now let's talk about stacks, which are data structures that follow the last in, first out, LIFO principle, meaning the last item added is the first one to be removed. Stack equal square brackets. So we are going to simulate a stack-like structure using a list. Stack dot append, parenthesis, quotation marks, a. New line, print, parenthesis, type, parenthesis, stack. Comma, stack. Now let's run it. As you can see, this stack is a list. But as long as we only use the append method to add elements, we can say it behaves like a stack. Stack dot append, parenthesis, quotation marks, b. Let's copy this line and let's change it. C. New line, print, parenthesis, stack. It behaves as a stack. So, if append is the method to add elements, which method do we use to remove elements? Let's see. So, stack dot pop, parenthesis, new line, print, parenthesis, stack. So, by using these two methods, append to add and pop without parameters to remove elements, we are managing a stack while respecting the last in, first out, LIFO rule. Now let's talk about queue. Queue equal queue, parenthesis, new line, print, parenthesis, type, parenthesis, queue, comma, queue dot queue. And let's run it. And as you can see, we created our first queue. Let's do something with it. New line, queue dot put, parenthesis, quotation marks, 1. New line, print, parenthesis, queue dot queue. A queue also follows a rule similar to that of a stack, but instead it uses the first in, first out, FIFO principle. Now let's copy this line and add other two elements. 3, 2. So we discovered the method to add elements. Now, what's the method to remove them? Let's see. Q dot get, parenthesis, new line, print, parenthesis, Q dot Q. Let's copy these lines and let's run it. And as you can see, we removed two elements from the queue following the first in, first out FIFO rule, leaving only the last element we inserted. So now let's talk another structure, which is a linked list. We need to create two classes. Class, node, column, new line, def, init. Let's add data and self dot data equal data. self dot next equal none. Let's create the other class linked list, column, new line, def, double underscore, init, self dot head equal none. A linked list is composed of multiple nodes, where each node points to the next one until the last node points to none. So let's create a linked list, L equal linked list, parentheses, and let's create a node. N1 equal node, parentheses, 1. L dot head equal N1. New line, print, parentheses, L dot head, comma, L dot head dot next. You can think of this as the address where the object is stored, and none as the next location, meaning there is no next element, so there is no address to point to. So let's create other nodes, n2 equal node, parentheses, 2. New line, n3 equal node, parentheses, 3. And now let's connect those to the linked list. L dot head dot next equal n2. New line, n2 dot next equal n3. And let's print all the nodes. New line, print, parentheses, n1, comma, n1 dot next. Let's copy this line twice and set this to 3 and this 2 and again this 2 and 3, and let's run it. And as you can see, this is the address of the object and this is the address of the next one, which as you can see matches the actual address of the next object, and so on, till the none. So how to print the list easily? Let's do it. Current equal n1. New line, while current, column, new line, print, parentheses, current dot data, comma, and equal, quotation marks, hyphen, greater than, new line, current equal current dot next. New line, else, column, new line, print, parentheses, current. And let's run it. As you can see, these are the data contained in any node, the first, the second, the third. So let's recap. Lesson 28 hyphen data structure. New line, we learn about bytes, byte arrays, stack, which remember LIFO, last in first out, Q, FIFO, first in first out, and linked list. For this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to talk about Jupyter notebooks, which you may encounter in data science and machine learning, mostly in online notebooks or platforms like Google Colab. So let's get started. First of all, we need to install a module, so Python -m pip install ipykernel -U -force -reinstall. Then we are going to install two other modules, pip install pandas matplotlib. Pandas and matplotlib are often used with Jupyter notebooks because of their seamless integration and ability to display data and visualization directly within the notebook environment. Now let's close the terminal and create our first notebook. Notebook.ipynb. And as you can see, it's quite different from what we are used to. In this environment, you can create two types of cells. Let's start by creating the first type. Let's write something. Here you can write in Markdown. So one hashed creates a title. First, Jupyter notebook. New line. Double hash creates a subtitle. Pandas. New line. Triple hash creates a smaller heading. Matplotlib. And now we can create a cell where we can write code by clicking here. If your cell doesn't show Python in the bottom right corner, you can click on the three dots and select the Python from the menu. Now let's write something, print, parentheses, quotation marks, notebook. And now we can choose to run in order all the notebook or only this cell. So let's run this cell. And as you can see, we printed notebook. Now let's create another markdown. Hash import. Now let's create a code cell. Import pandas as PD. New line. Import matplotlib.pyplot as plt. New markdown cell, hash data, and new code cell. Data equal curly brackets, quotation marks, month, colon, square brackets, quotation marks, Jan, comma, quotation marks, Feb, comma, quotation marks, Mar, comma, quotation marks, April, comma, quotation marks, May, comma, new line, sales, column, square brackets, 250, comma, 300, comma, 400, comma, 500, comma, 200. Let's go a bit down. New line, quotation marks, expenses, column, square brackets, 100, comma, 110, comma, 200, comma, 300, comma, 150. And then let's create a data frame, df equal pd dot data frame, parenthesis, data, new line, print, parenthesis, quotation marks, data frame, column, new line, print, parenthesis, df. Now let's run the cell, but before running a cell, we need to make sure we have run any previous cells it depends on. So first, let's run the import cell, and then we can run our new cell. And as you can see, we can see our data frame as it was in a database. Now let's create another markdown cell, hash profit, and a code cell, df square brackets, quotation marks, profit, equal df square brackets, quotation marks, sales, minus df square brackets, quotation marks, expenses, new line, print, parenthesis, quotation marks, data frame with profit, column, new line, print, parenthesis, df. And let's run it. As you can see, we added a column, profit column. Now let's create another markdown cell, hash summary. Let's create a code cell, print, parenthesis, quotation marks, summary, statistics, column, new line, print, parenthesis, df dot describe, parenthesis, and let's run it. And as you can see, we obtained a lot of statistical information about our dataset. Now, let's create a graph, hash graph, code cell, and plt dot figure, parenthesis, fig size equal, parenthesis, 10,5, line, plt dot plot, parenthesis, df square brackets, quotation marks, month, comma, df square brackets, quotation marks, sales, comma, label equal, quotation marks, sales, comma, marker equal, quotation marks, O. Let's copy this line and let's change this to profit. Let's copy and paste it, and here expenses. Let's copy and paste it. then new line, plt dot title, parentheses, quotation marks, monthly data. New line, plt dot x label, parentheses, quotation marks, month. New line, plt dot y label, parentheses, quotation marks, amount. New line, plt dot legend, parentheses, new line, plt dot grid, parentheses, true. New line, plt dot type layout, parentheses, new line, plt dot show, parentheses, and let's run it. And as you can see, it works. If you want, you can also save the plot image. And for this lesson it's enough. Thanks for watching and see you in the next lesson. Hi guys, in this lesson we are going to create a multi-client chat application, so let's get started. First of all, here is the .env file. Make sure to set a long and secure Flask secret key. Also set the port as I did. If you want to communicate with different clients on your local network, you can set the host to your local IP address. Now let's import some module. Pip install Flask socket IO python -.env. Let's push enter. Load _.env, parentheses, new line, app equal Flask, parentheses, name, new line, app.config, square brackets, quotation marks, secret _key equal os.getEnv, parentheses, quotation marks, Flask secret key. New line, socket IO equal socket IO, parentheses, app. Host equal os.getEnv, parentheses, quotation marks, Flask host. New line, port equal int, parentheses, os.getEnv, parentheses, quotation marks, Flask port. New line, socket IO dot run, parentheses, app, comma, host, comma, port. And then we have to create also two functions, at app dot route, parentheses, quotation marks, slash. New line, def index, parentheses, colon, new line, return render template, parenthesis, quotation marks, chat.html. Line at socket.io dot on, parenthesis, quotation marks, message. New line def handle underscore message, parenthesis, msg, colon, new line, let's print it, print, parenthesis, f-string, message, colon, curly brackets, msg. New line, send, parenthesis, msg, comma, broadcast, equal, true. So in this script we create a Flask application and add real-time communication using socket.io. When someone visits the root URL, the server renders the chat.html file, which we'll create. The server also handles incoming messages and broadcasts them to all connected clients, allowing for real-time chat functionality. Let's create the template chat.html. Now we are going to learn a bit about HTML, which is the standard language used to create and structure content on the web. HTML stands for Hypertext Markup Language, and it allows us to define elements like headings, paragraph buttons, input fields, and much more. In our case, we'll use HTML to build the layout of our chat interface, where users can type messages, see messages from others, and interact with the app in real time. Doctype, HTML, head, title, chat, room, line, link, curly brackets, URL underscore 4, parentheses, quotation marks, static, comma, file name equal css / style dot css. New line, script src equal quotation marks https / cdn dot socket dot io / 4.7.2 / socket dot io dot min dot js. And then let's create the body, div, new line, id equal quotation marks chat hyphen container, class equal quotation marks chat container, new line, div, id equal quotation marks chat hyphen box, new line, div, id equal input area, new line, input. Let's remove this part. ID equal quotation marks username, placeholder equal, enter your name, new line, input, ID equal message, placeholder equal type your message, autocomplete equal off, new line, button, on click equal quotation marks, send message, parenthesis, send. So we are connecting this button to the function send message that we are going to create. Now, out of the div, let's import another script src equal quotation marks, curly brackets, url underscore for parenthesis, quotation marks, static, comma, file name equal quotation marks js/chat.js. And that's it. So now let's create this JS file. Chat.js. And let's write our first JavaScript file. And now let's create a JavaScript file which will handle the interactive part of our chat application. JavaScript allows us to add dynamic behavior to our HTML, such as sending and receiving messages in real time using socket.io. In this file, we'll connect the server listen for incoming messages and emit new messages when the user sends them from the chat input. Const socket equal io parenthesis semicolon new line const chat box equal document dot get element by id parenthesis quotation marks chat hyphen box semicolon new line socket dot on parenthesis quotation marks message comma function parenthesis msg curly brackets new line const msg div equal document dot create element parenthesis quotation marks div semicolon new line msg div dot class list dot add parenthesis quotation marks chat hyphen message semicolon new line msg div dot text content equal msg, semicolon, new line, chatbox dot append child, parenthesis, msg div, semicolon, new line, chatbox dot scroll, top equal chatbox dot scroll height, semicolon, next line, semicolon, new line, and let's create a function send message, parenthesis, curly brackets, new line, const username equal document dot get element by id, parenthesis, quotation marks, username, dot value, semicolon, new line, const message equal document dot get element by id, parenthesis, quotation marks, message dot value, semicolon, new line, if, parenthesis, message dot trim, parenthesis, exclamation mark double equal, quotation marks, curly brackets, new line, socket dot send, parenthesis, username plus quotation marks, column plus message, semicolon, new line, document dot get element by id, parenthesis, message dot value equal quotation marks, semicolon, and let's save it and close it. Now it should already does something, our program, so let's run it and let's click on Control and click on the link. It should open your browser at that link, and as you can see there is everything we created in HTML. Let's try the JavaScript and Python part. Red Python. Oh, okay, it works. Let's open another browser. Edge 127.0.0.1 colon 5000. Okay, let's split the screen and let's try to send back a message from Edge. Blue JavaScript. As you can see on our Firefox, the message has arrived. Now, as you can see, it's too minimal, this look, so let's try to do something better, creating a style.css file. New file, style.css. Here we can change the appearance of the HTML to make it look better. So let's stop the program. Body, curly brackets, new line, font family, question marks, Arial, comma, sans serif, new line, background, hash, E5, 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 new line, display, flex, new line, justify content, center, new line, align items, center, new line, 8, 100, VH, new line, margin, 0. This way we've made the body tag look nicer. Now let's improve the appearance of all the elements with a specific ID. Hash chat-container. By using hash, we can select any element with a specific ID that we have defined in our HTML file. Max width 500 px, new line, 8 600 px, new line, display flex, new line. Instead, by using dot, we can select elements by their class. Dot chat-container, new line, flex direction, column, new line, border, radius 16 px, box shadow 0, 8 px, 30 px, RGBA parenthesis 0, 0, 0, 0.1, new line, overflow, hidden. Let's take another ID, hash chat-box, curly brackets, new line, flex 1, new line, padding 20 px, new line, overflow y, outlaw, new line, background, hash f9, 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 new line, flex direction, column, new line, gap, column, 10 px, input, area, curly brackets, padding 15 px, new line, border, top 1 px, solid, hash ddd, new line, background, hash fff, new line, display flex, new line, gap 10 px, new line, flex wrap, new line, input, comma, button. We can also call multi-tags. Font size 14 px. New line. Padding 10 px. New line. Border 8 px. Border 1 px. Solid hash CCC. New line. Flex 1 1 auto. New line. Hash username. Curly brackets. Flex 1 1 30%. New line. Hash message. Curly brackets. New line. Flex column 1 1 60%. New line. Button. Background. Hash 007 BFF. New line. Color. Hash FFF. New line. Border. None. New line. Cursor. Pointer. New line. Button, column, hover. Curly brackets. New line. Background. Hash 0056 B3. New line. Dot chat hyphen message. Curly brackets. New line. Max width column 75%. New line. Padding 10 px 14 px. New line. Border radius 16 px. New line. Font size 14 px. New line. Word wrap break word. New line. Color hash 0000. Let's save and close it. Let's try to run it again. And as you can see, it looks nicer. So let's try to send some message. Python. Blue. JavaScript. One last thing, we could change the side of the sender and the receiver. Let's try to do it. Stop the program. Chat.js. Const username equal document dot get element by id parentheses quotation marks username dot value, semicolon, new line, const, sender equal msg dot split, parentheses, quotation marks, column, square brackets, 0, semicolon, new line, if, parentheses, sender dot trim, parentheses, triple equal, username dot trim, parentheses, curly brackets, new line, msg div dot class list dot add, parentheses, quotation marks, sender, new line, else, curly brackets, msg div dot class list dot add, parentheses, quotation marks, receiver. And don't forget the semicolon. And let's change also the style.css, new line dot chat message dot receiver, curly brackets, align self, flex start, new line, background, hash e3 f2 fd. New line dot chat message dot sender, curly brackets, align self, flex end, new line, background, hash d1 e7 dd. And let's save it. And let's try to run it again. Let's open Firefox and Edge. Python. And as you can see, the sender and the receiver take different positions. In both the clients, so it worked pretty well. So for this lesson it's enough. Thanks for watching and see you in the next lesson.